Well, hello, my name's Ed Donner. I'm a two-time AI startup co-founder and a former managing director from JP Morgan, and I'm about to take you on a wild ride. We're going to be spending the next 6 weeks together on an adventure. I've actually just finished myself doing the 6 weeks worth of projects. There are 8 projects along the way, and I can tell you, I have some astonishing things in store for you, and I can't wait to get started. Let's do this. Now, it's customary with these things to kick off with an introduction to myself and talk about the goals of the course, but people who've taken my courses before will know that I don't like doing that. Let's not do that. Let's get straight to action. Let's go and see some autonomous AI agents in practice, and we'll come back and do that other stuff later. So I've taken us now to the app N8N, which is an exciting app that is definitely generating interest. This is an example of one of these low-code or no-code workflow apps that allows you to construct a workflow of orchestrating between different applications and build it without necessarily needing to write any code yourself. The difference with some of the other workflow tools like this is that it has generative AI built into it. And that's why people are so excited about N8N. So if you come to n8n.io, which is the cloud version of it, you can also download it and run it locally. But here we're using it in the cloud. You can press Get Started and set up an account if you want to do this yourself, or you can just watch me. But it might be fun to try this out yourself if you haven't used it before. So I've set up an account, I've done that. And once I've signed in, I get this beginning screen to add my first step. You can also use one of their templates right off the bat if you want to. But we're going to build something ourselves right now. So we're going to add a first step. And what we're going to do is we're going to begin by starting with a chat message. So this, if I go back to the canvas here, you press back to canvas on the top left, we can now see this canvas, which is showing that we have a chat box here that's represented by this chat window down here. And we can chat and do something as a result of that chat. So what do we want to do? Well, we press the plus button right here. And we come over to the right and we decide that we want to have advanced AI, and we're going to create an AI agent right here. And now if I go back to Canvas, I'll show you that what we have in our canvas now is a chat message going into an AI agent represented by this box, and then something can come out of the back of that. And you don't need to know all of the details here. This is more to give you an idea, and by all means you can play with this yourself, but most of this course is going to be about building things like this. But let's give this a shot. So the next thing we can do is add a chat model. And this is a large language model that's going to sit behind this AI agent. And I'm going to pick OpenAI chat model. Now that's because I have an OpenAI key, which we'll be setting up for you if you don't have one already quite soon. And alternatively, if you don't want to do this, you can use Ollama instead and run for free, but you would then have to install it locally. But I've set up my OpenAI account, and you can do this yourself. All you do is you come down here and you press create new credential and you type in your API key. But I've done that already, so my OpenAI account is linked. It's as simple as that. And here it is. It looks here. OpenAI chat is connected to my chat model. So far, so good. Let's keep moving. We're now going to add in a tool. Now, tools are one of the most fundamental building blocks of agentic AI. And this week is going to be a lot about building tools. So I press the plus button to open up the list of tools that I could connect with the AI agent. And you can see there's a large number of tools, a lot of different things that this agent could use, could take advantage of. It could do calculations with a calculator. It can book meetings using my Google Calendar or read my emails, look at my Facebook timeline. Lots of things that it can do, as you will see here. Read Hacker News for me. I would like that. Okay, but we're going to go all the way down and we're going to find something here that I just want to show off, which is the Philips Hue tool. I don't know if you know about Philips Hue. It's something which is gives you light bulbs, and I have a lot of light bulbs in my apartment here. And we're just going to pick a light bulb, this one here called the bed strip, and we can add a field. We'll say brightness. We'll let the AI automatically choose what it wants to do with brightness. We'll add a field hue, which is like the color, and we'll let it do that too. And that's all there is to it. We've now, when I go back to the canvas, you'll see that we have given a tool to this agent that you can see visually here that it is able to control the Philips Hue light bulb. So here we are looking at our chat, our agent, the LLM, and the tool. Let's get going with bringing up the chat message that's associated with this input. And let's say, well, hi there. And you can see it working and thinking, hello, how may I assist you today? Let's say, please turn the lights on bright white. And let's see, and bam! Did you see that coming? On come the lights that I am, in fact, wearing my light strip. So here we go. Now, you may say to me, okay, that's cool. I see tools in action. I see an LLM that I'm chatting with that's controlling my lights in my apartment. Great. But it's not really showing me autonomy. I'm not seeing something where it's making its own decision. Well, then let me show you that. So to make it autonomous, we need to give this agent some agency. So let's say, please pick a color. Let's say either deep red or deep blue, and change the lights to that color. Let's see how it does with that. And there we go. A lovely red comes out. Fantastic. So there you have it. We have an autonomous agent. Maybe it's a simple task, but nonetheless, you just saw it making its own decision, picking red over blue and changing the light bulb all through N8N's web app. So look, that was a bit small and superficial, but nonetheless, it was our first foray into the world of agentic AI. And I strongly encourage you to go and take a look at N8N. It's so easy to use. It's so quick to set up an account, to hook up a web form to your Google Calendar, and lots of other things to try out. And it gives you a nice hands-on sense of what it's like to work with agents. But I should say, this is the last time that we'll be using a tool, a low-code, no-code tool like this as a user of AI. For the next 6 weeks, we're going to be rolling up our sleeves and we're going to be coding agents. We're going to be building them ourselves and working with frameworks that allow us to build and have different agents interact, be orchestrated to solve problems. Okay, so in the next lecture, I will tell you more about what I have in store for you. See you then. So as promised, I'm coming back now to tell you what this course is actually about. We're going to be doing 3 things. We're going to be working on theory, talking about what agents are and what an agentic architecture looks like. We're going to be talking about frameworks, so working with actual platforms that allow us to build and deploy AI agents. And of course, we're going to be getting hands-on, rolling our sleeves up, building some projects. Some of the projects will be more on the sort of entertaining side. Some of them will be much more on the commercial side, building real functionality. All of them will be fun. So I've organized the curriculum into 6 modules that I call the weeks, week 1 through to week 6. And I do that because I want to give you some motivation to be pushing on through this and keep up the drive. But you can take it at whatever pace you like. And if you can do it faster than 6 weeks, then so much the better. But that's how I've structured it. And each week builds on the last. The first week that we're on right now is called Foundations, and it's all about grounding you, building out the basics, talking about what it takes to have an agentic architecture, how different LLMs can interact. And we're going to be building an agentic solution just with LLMs interacting natively, not going through a framework. But in week 2, we introduce our first framework, the OpenAI Agents SDK, which is a beautiful framework because it's so simple and elegant and flexible, and we'll build some things with it. We'll add guardrails. It's going to be really great. In week 3, though, we move to the very popular CrewAI. I'd say that Crew is the fan favorite. People love Crew. It's on the sort of low code end of the spectrum. It allows you to write some configuration and use that to define your crew of agents that will solve your task. And it's a lot of fun to work with. Perhaps on the opposite end of the scale in terms of code, of low code to full code, is LangGraph, which is very sophisticated, quite complex, very powerful, and we will be using all of its power. And in week 5, another powerful one is Microsoft's AutoGen. AutoGen is actually a couple of different things, and we'll look at all of them. But one of the things it is like an environment where agents can collaborate remotely, and that's going to be fun. And we wrap it up in week 6 with our capstone project and introducing MCP, the Model Context Protocol from Anthropic. Incredibly exciting, and it's really taking off in a big way. This is an open source way that different models can connect and collaborate, share each other's capabilities using a common protocol. So I'm really excited to show it to you. It makes a lot of sense to have that in week 6 because we're going to draw on a lot of the things we've learned about in prior weeks. It's all going to come together, and that's very much the idea of this structure. Each week builds on the last as you build up your capabilities and you upskill all the way through to the end of week 6 when you will have mastered engineering AI agents. And each week consists of 5 days, 5 different sets of lectures to build up your skill sets during that week. I give you Saturday and Sunday off. So just to show you what it looks like, I'm not going to talk to what we're going to do on every single one of the days. I want to give you that sense that there's a lot going on. We're going to cover a lot of stuff. And this is color coordinated to match an earlier slide that orange represents some theory building. Yellow is the project. And that first project we're going to do at the end of this week is going to be really cool, really fun, something that you'll be able to put into practice. Building your own agent that you'll be able to deploy into production that we will do that is able to answer career questions about yourself. It will be like your career alter ego that you can put on your website. Instead of having a resume, people can talk to you and talk about your experience and your challenges and so on. Isn't that cool? We're going to be doing that in the next few days. That's week 1. Week 2, we're going to be, as I say, OpenAI Agents SDK. You'll see that the blue here, blue boxes represents a new framework that we are learning. And again, the yellow are the projects, including deep research, which will be a great app. Week 3 with Crew, you can see we're going to learn about Crew and then build a couple of different projects with Crew. Week 4 is LangGraph. Week 5 is AutoGen. And then week 6 is MCP and the capstone project, which is going to come at the end of this course, bringing everything together. So as I say, I'm not putting this up here to show you every single box. I'm doing it so you see we've got a lot of material to cover. There's a lot of areas in which we'll be growing skills. And by the end of it, you'll have ticked off everything you see here on this screen, the complete curriculum, and you will have true expertise in the world of AI agents. And I'm now just going to color in the boxes which represent the delivery of major projects. And in particular, I would say that the numbers 5, 6, 7, and 8 are some of the really exciting ones I have in store for you. I've just finished building them and I had so much fun doing it, and I can't wait to share it with you. And just to show you that it's definitely worth hanging on in there for the next few weeks, let me tell you about those last 4 projects. One of them is writing an agentic platform that's going to represent a whole engineering team, a team of different people, a front-end developer, a back-end developer, an engineering lead, and a tester that will collaborate together to write some software for us, and we'll see them all in action. One of them will be, I call it Sidekick. It's going to be an agentic platform that will be able to bring up a browser and interact in that browser together with you. So you will have your own sidekick that can do things with you. It's a bit like a Manus, if you know Manus, of course, the Chinese agentic startup that's really caused, again, a lot of excitement. But Manus runs its platform in a sort of cloud box that you can't control. You can just watch it doing its thing. You'll have something a bit like that, but it will be on your box and you can work with it side by side, a true sidekick. Project 7, I call Creator, and this one isn't particularly commercial. It's just really interesting that this is one where we will build an agentic framework that is itself able to create new agents. It will actually give rise to agents, an agentic platform that generates agents. And we're going to have those agents doing some commercial stuff, just so there is a commercial angle to it. And Project 8, the capstone project, is something that I've wanted to build for so long, and I'm so happy to get to do it. This is a financial markets trading simulation where we will have multiple agents that can actually go off and make investment decisions, searching the internet for financial news, looking up stock prices, true real-time stock prices, and company information, and read company annual reports, SEC filings, and then make buy and sell decisions trading on the market. Now, that part is the simulated part, that we'll have some code that will just keep track of their accounts. And by the way, the code that we'll have keeping track of their accounts is code that will have been written by Project 5, by our engineering team, not by us. Just to add an extra dimension to this, some of the code will have been written by our agentic engineering team. But what you see here in this screenshot is the results of this just running yesterday, and it was actually a really terrible day on the stock market. So all 3 agents lost money this day, but hopefully by the time that we get to week 6, they will have recovered and we'll be able to actually show some profits that we're making in our virtual world. And of course, I should say now, and I will say then, that this should not be used for any real investment decisions. Of course, this is purely illustrative, but as an illustrative project, it's going to be a lot of fun. And while I hope that all of these projects will be entertaining, I will be trying to achieve 2 things from them. One of them is to have them be highly educational. Each project should allow you to upskill your capabilities and your expertise. The other is that I want them to be commercial. They should help you to have ideas of how you can apply this skill in business, whether it's a B2B or B2C kind of project. This should equip you to be able to put this into practice immediately, the very next day, on commercial projects. So now, just to introduce myself very quickly, just to show you that I am actually qualified to be talking to you about this stuff. So my name's Ed Donner. I spent most of my career at JP Morgan, where I ran engineering and science teams of about 300 people. I started out in London, which is where I'm from originally, if you couldn't tell from the accent. And then I moved to Tokyo for a bit, and now I am based in New York. And I'm currently the CTO, co-founder of an AI startup called Nebula. It's at nebula.io. You can go and check it out. And prior to that, I founded my own AI startup called Untapped. And actually, Untapped was acquired in 2021. And this picture on the bottom left is a picture from the billboard in Times Square announcing our acquisition, which was a particularly magical day for me. So that was a really incredible moment. But I don't just show you this picture to show off about my moment in Times Square, but also because I happen to live about 1 block that away. If that guitar weren't there in the Hard Rock Cafe, you'd be able to see my apartment building. And I'm facing the window right now that is facing there. So in some way, if that guitar weren't there and this was some kind of a live feed, then you would see me waving at you right now or something. Another thing that I do is I love to be a speaker and instructor on all things LLM, and I have another Udemy course called LLM Engineering, which has got 60,000 plus people on it and has been just an absolute joy. And I hope that some people that are on this now have actually taken that LLM engineering course, in which case I must apologize to you because you heard almost exactly this same introduction when you took that course too. So sorry, I hope you sped through it this second time round. Maybe it gets better on the second time, I don't know. Anyway, final thing to say, which I also said last time, is that here's a picture of me about to fly a plane. And you might think I'm showing you this because I am fabulously capable at flying planes. But no, au contraire, I'm showing you this because my great skills in the field of LLM and agentic AI is only surpassed by my complete inability to do anything requiring hand-eye coordination. So, in fact, if you find yourself in a plane and you look in the cockpit and you see that it's me there in front of the stick, then you want to be looking for a parachute as quickly as you can. But by contrast, if you find yourself taking a course about agentic AI and I am the course instructor, then you've come to the right place. This is completely in my wheelhouse. All right, let's get to it. So please humor me. I've got a couple more admin things before we get into action. So I wanted to talk about how I've positioned this course and whether it's right for you. You may be new to coding, someone that's never written a line of code before. You might be someone that's already considers yourself an agent engineer. Those are the two extremes. Or you might be in the middle. You're already a Python coder, or you are an AI engineer. Maybe you're even someone that's taken my LLM engineering course, in which case, thank you and welcome. But I'm here to tell you that this course is designed to appeal to everyone across that entire continuum. There is something here for everyone. The people in the yellow boxes in the middle, you're going to have the best time with this. It's most well positioned for you. That is for sure. That goes without saying. For the people that are new to coding, it's going to be challenging. There's no doubt. You're going to have a lot of patience, but this course is okay. You'll be able to get there and build amazing things. For someone who's already an agent engineer that's built some agent platforms before, you may want to speed through some of this, but I've made sure that there's advanced material covered too. We're going to be doing some really interesting things at every point and building some great projects too. So I'm here to say, if you're new to coding, take some time with the guides that I've written. You'll find them in the guides folder when we install the repo. And I've used that as a way to build up your foundational expertise so that you can hit the ground running. For Python coders and particularly for AI engineers, if you've taken the LLM engineering course, it's perfect. Then you're going to have a great time. And for agent engineer, focus on the projects. That's when we really put things into action. I'm really proud of the projects we've built. I think you're going to enjoy them, even if you've got some experience with this already. And for anyone that hasn't taken the LLM engineering course, I'll be sure to put links to it in the course resources. And it's something that I really do see that as complementary, and it's not necessarily a prerequisite to this course. You can come into this course without having taken it for sure. But if you have taken it, you will be really well equipped for this course because it builds up a lot of depth of expertise in terms of what it means to work, to choose and apply LLMs to solve problems. So in just a moment, we're going to be starting to code. I know you're antsy. I know you're waiting for this. Can't he stop talking and get to it? We will be. But I do want to tell you that the first thing we're going to have to do is set up your environment. And setting up an environment, a big data science environment at the frontier of what's possible, it can be a bit of a painful process. I'm here to help. I'm here to make it go smoothly, but please do have something of a thick skin for knowing that you may hit some challenges. We'll figure them out. We'll get them fixed. We'll get you up and running. This time, though, we're going to be helped out by a couple of really great friends in the form of the platform Cursor, which we'll be using as our IDE. And I just love Cursor. Cursor, of course, is the AI platform that's powered by LLMs that allows us to be so productive, and it's built on VS Code and it's just great. And so it's going to be a lot of fun working with that. But perhaps more specifically for building the environment, we're going to be using this product called UV, which is, you can think of as something which is replacing Anaconda that I used in the LLM engineering course. And it's a sort of built on top of using virtual environments. It's really fast and it's really simple and it just works. I am such a fan of UV. It's actually a student on the LLM engineering course that first drew my attention to it and said, this is what we should be using. And it was too late for LLM engineering, but it's not too late for this course. And it turns out that UV has become so popular that most of the agent frameworks we'll be looking at already have UV at their core. Crew is kind of like built with UV, as you'll see. So UV is really easy to use. It is nothing like Anaconda for people that have done this before. And it's basically very, very similar to using virtual LLMs, and you are going to love it. So I know it's always annoying to have to bring in something new to the mix, but it will be worth it. You're going to thank me for this. You're going to love UV, and it's written in Rust, and everyone loves things that are written in Rust. So there you go. Get ready for that. There's actually one more difficult conversation that we have to have, and it's about APIs. So look, this course does involve making calls to frontier models like OpenAI and DeepSeek, and they come at a price. There is a price point there. And I want to make the point that it is completely up to you. You can choose, I use both OpenAI and DeepSeek, but you can choose to only use DeepSeek throughout for a much lower cost. And Gemini you can also use, and right now Gemini has a free tier. I don't know how long that will last, but so you can use Gemini for free for most of the course. You can also use Ollama completely free just running open source models locally on your computer, no cost at all. But there are some trade-offs here. If you want to use any kind of good model, it will take a very long time. If you use the quick models like Llama 3.2, then it might have troubles being coherent, and you certainly won't get to see the kinds of results that I'll be getting when I'm using the frontier models. But that allows you to have a sort of balance. You can run things locally for free and see one set of results, and you can watch me do it with the frontier models if you don't want to spend the API charges yourself. So what are these API charges? Well, different countries might have different pricing. What I can tell you is that for me running this entire course, I spent well under $5 on any of the LLM model costs. It's very cheap. OpenAI, the first time you use it, you need to put down at least $5 up front and a kind of pay as you go that you spend against. So that's annoying. So you might have to do that if you haven't done it before. But other than that, the actual amount that we'll spend will be relatively small, a matter of a few dollars. And it's very hard to spend very much on DeepSeek because it's so cheap. Now, I will say that in the last week, I have an option to use a proper real-time market data provider that I use, and that costs me $20. But that's not necessary. There are free options as well. But if you get into it like I do, then you might do that. And, I just want to make the point at the end. People do have like people get frustrated about API costs. There's something about them that are a bit galling because it feels like everyone is sort of nickel and diming you. You're getting charged a little bit here, a little bit there, another API cost. And I understand that even though I say these things are very cheap, a few dollars, it adds up. And that's not always cheap. And particularly with exchange rates in different economies, that might be quite a burden. But I do want to make the point that you have to keep in mind what's going on when we run inference on these large LLMs. There are trillions of floating point calculations going on. This is heavy machinery. And so it's not like these companies are just making extra cash off you. I'm sure they are quite profitable, but most of it, the margins are relatively slim because there's a lot of compute cost associated with running these massive models. And if you think of the price of buying a new laptop or even a big, like a gamer box that could actually run larger models itself, you'd be talking about thousands of dollars. So this kind of API pricing, while it can feel, as I say, a little bit galling sometimes, having to pay each of these different APIs, it is worth keeping in mind the context of what's going on behind the scenes. These companies need to pay their electricity bills. There's a lot of compute, and we're getting real value from what we use. So I don't know if that helps or not, but it gives you some context. Please do keep in mind, you don't need to spend anything on APIs if you don't want to. So there are 3 things for you to remember. The first of them is that there are resources that accompany this course, and they're really great. There's a website where I've put links and I've got extra content in the form of YouTube videos that should be helpful. In GitHub, there's a whole section with different guides to teach different kinds of skills that you might need. And there's some troubleshooting guides in there too that will fix problems for you. And the labs, I'm updating them all the time. The labs, you can think of them as like an ongoing, a fluid resource. Every time you do a Git pull to get the latest, you'll get refreshed with new content. Maybe not every time, but most times. I'm trying to keep them to be a living, breathing resource for you. Then remember to stay patient. Remember that if you hit problems, if you hit roadblocks, that's actually a great learning opportunity because figuring out what's going on, figuring out how to solve this is one of the best ways to learn. And try and go with it, try and enjoy it as much as you can. There's some juicy projects, and figuring out why they don't work first time, that's part of the fun. And then the third point is that if all else fails, or even if nothing else fails, then contact me. I'm here. I love this stuff. I'm actually super responsive. If you email me or if you LinkedIn with me, then I'll respond very quickly, unless I'm in a meeting or I'm traveling or something, or I'm asleep for people in different time zones. I do tend to reply really quickly. People are always surprised. In fact, a lot of people think that I'm an AI agent when I reply. They're like, Ed, do you have an agent of yourself? But no, it's the real me. I will reply. I love getting questions. I love answering. So do feel free to reach out, be in touch. I welcome ideas and thoughts and questions and whatever you got. And by all means, if you're up for it, then LinkedIn with me. Some people don't feel comfortable doing that for some reason, but I'm very open to it. I love building a community of people in data science and that can support each other. If people are looking to hire someone, or if they're looking for jobs, then I can help connect people. So it's a really great way for me to build and contribute to the community. And this is really important. But one of the things that people did from my last course is they would post projects that they've done and tag me on them, or things that they've done from the course. And I can then amplify it, because I can then jump in with some comments and make some observations, or say how great it is they've done something. And that will then be available to all the other students from the course. You can weigh in as well. And this has really happened, and it allows you to share things and amplify them. And LinkedIn is a great place to do that. And it will be something that will be seen perhaps by future clients of yours, or perhaps by future employers of yours as well. So it's a really good thing to do. So I strongly encourage it. LinkedIn with me and share on LinkedIn. It's a great resource, and I can't wait to see what you're doing. So at this point, you put up with half an hour of me yabbering away. Finally, it's time for action. We're going to the lab. We're going to set up your environment. The next video is for PC people. We're going to have a video for PC setup. And then the video after that is for Mac people and Linux. You should probably join in with the Mac people. It'll be similar enough for you. And then we will reconvene on the video after that. So it's going to be PC, followed by Mac, followed by us all back together again with fully built environments. Let's do it. Well, if you're a PC person, then you've come to the right place. This is for you. If you're not a PC person, then get out. You're not welcome here. All right, with that out of the way, hello. This is the video when we actually get to set up your environment. And there are going to be 5 steps to doing this. The 6th one will be somewhat optional. There will be a 6th step, but the 5 main steps we are going to do, and they are going to be covered in my repo very clearly. And let's start by going there. We're going to go to the repo that is linked in the course materials. It's at github/myname/agents. And here it is. And when you go there, you see the different directories, the different folder structure that we have. And if you scroll down, you get what's known as the README, the set of information that comes with the course. And I plead with you to read the README. I put a lot of care into the README. It's got lots of great stuff in there. And so do take a look through it, and it will set you up to be successful. In addition to another link to my LinkedIn, I'm starting to sound a bit desperate about this. There's also lots of useful things. And most importantly, there's links to the setup instructions, the Windows setup instructions, the Mac and the Linux ones. And I'm not going to take you through them right now, because this will be a living, breathing document that I will keep it updated as people hit problems. But you should go through that and have that side by side. If anything, that's going to be better than this video. See this video as bringing it to life, but the instructions will be bulletproof. So it's time for step 1. And just before starting step 1, I do want to draw your attention to a section at the top of the Setup PC guide that's called Gotchas, and it has a few of the common traps that can happen when setting things up for PCs. One of them is an insidious problem with Windows sometimes being set up to not allow names of files longer than 260 characters. And if that is set on your system, then you need to unset it so you are allowed longer file names. And that's something which there are instructions for how to do that. Another common trap is around antivirus software that can interfere with the installation. So there's some steps there as well. So please do look at those gotchas, because they will set you on a good path. All right, step 1 is about cloning the repo using Git. And to get started, if you go to the Start menu and you then type PowerShell, you should be able to open up a PowerShell, one of these things. Let me get rid of the other one that's running here. So here is a PowerShell. And this is like for running commands in the command line. If you're new to this, one of the guides in the guide folder in the repo contains within it, so in this guides folder, there is a guide for using the command prompt that will put you in good shape. But I'm imagining at this point you are familiar, so you know that there could be a projects directory. Most people have created a projects directory in which you should go into it. If you don't already have a projects directory, then you should create one with mkdir projects within your home directory. So you will then have like I do, a projects directory within your home directory. And if I look at the contents of it, it has my LLM engineering folder from my other course, and it has some test folder. And it is this folder that we're going to clone our new repo. First, we need to check that we have Git installed, Git for code management. And you can do that by typing git ---- version. And we'll see that I do indeed have Git installed. If you don't have Git installed and that has an error message, then you can go to Git's website, and there's a link in the setup instructions, and go to downloads and to Windows. And you can click here to download the latest version for Windows, and the installation instructions should be crystal clear, and make sure that you have that in there. You might need to open up a fresh PowerShell. Always worth knowing that you might need to do that. And sometimes you need to restart your computer. Super annoying, but hopefully not. You should be able to type git ---- version and see Git in there. Okay, so the next thing to do is to actually clone the repo. Okay, so we go to the repo itself. Here we have it. And the first thing we do is we go to this green button on the top right of the repo, as I'm looking at it here in a browser. And you click this code button, you select HTTPS, and you'll see the web address of this repo, and you press the copy URL to the clipboard button. And there we go, I have copied it. And now you come here to the PowerShell. Now, again, I'm in my projects directory. So you're in your home directory, then your project subdirectory. If your C drive is quite full, then you might want to do this on your D drive. Just make sure you're within a projects directory, a good place for it to be. And you simply type git clone, and then the paste in there the web address of the GitHub repo. And when we press enter, that runs, it does its thing, and it's done. And if I look at that directory, you'll now see that agents is there. I can now go into that directory agents and look at it. And here are all of the directories within the repo. And this folder that we're in right now, which is projects agents, this is what's sometimes known as the project root directory. That's what people call this. And it's a very common place to go. And this is where we are. And that means that we have completed step 1 of the 5-step process. Okay, so we go right away to cursor.com to look at the Cursor IDE, a fabulous platform, and download it and install it if you don't already have it. And you can just press the download for Windows button. It will download the executable, and you can then run it, and you'll get this setup screen, a familiar kind of setup. Accept the agreement, choose where you want it to install it, and I choose the C drive, but you could put it on the D drive if you're running out of space, and then next, and then we will create a desktop icon and add it to Windows Explorer. And note that it will make changes to path, which means that we will need to bring up a new command prompt for this to take effect. And then we will install that. So it will now install Cursor on my PC so that we can use this platform. And I will jump forwards and see you in a second. And Cursor has now installed, and so I can press finish, and it should now be installed and launching on my PC. There we go. It's right here. Oh no, it is starting. It is starting. Here it comes. It just took a moment, and we can just keep with all of these basics. And I'm going to select to use the word cursor if I want to run it from the command line, and say yes, okay, and then continue. And I'm going to have it in privacy mode. I'm not going to be logging what I do, and you are all set. So now you can sign up for a Cursor account, which is free, and you just press that sign up button and follow the process. And then once you're finished with that, I will see you back here in a second to actually use Cursor. And so here we are in Cursor. It's started. I've signed in. I've actually got a pro trial, and we're looking at the first screen we've got here, and I can press open project. And what I can now do is navigate. I'm gonna actually go this PC, and then to my C drive, and then to users and ed, and then projects, which is where my projects are. And here is agents. And this you'll recognize as the directories that we cloned from our repo. And what I can do now is just press this select folder button, which is saying, I want this agents folder to be my project root folder. And it opens up. This is your first look inside Cursor. We've got our directories down here. You've got like a welcome screen up here. I'm going to X out the welcome screen. And now here we have something called the Explorer on the left, which has all of our directories. We've got a chat ability to chat with an LLM on the right. I'm also just going to close that down. And what we're looking at here is the code. And in fact, this navigator on the left is showing you a different directory for each of the 6 weeks of the course from foundations through to MCP. And if we open this swizzly here, you'll see all of the contents of the first week foundations where we are right now. Okay, we're racing ahead to part 3 of the setup. Part 3, of course, is time for UV, which I'm so excited to show you. So we start by just looking for UV package manager. You will find it's also linked in the setup instructions. Astral is the name of the company that makes UV. Here it is, and it is an extremely fast package manager as it tells you. So to install for Windows, you simply run this in a PowerShell. And so I've pressed on Windows. I'm now going to press this copy button to copy that in, and I'm now going to go to a PowerShell, which we will do right here, PowerShell, and I'm going to run that command. So here we go. We'll let it do its thing. It's now installing UV, and that appears to have already happened. And it's telling you you can either restart your shell to take this into the path, or you can run those commands. We're going to restart our shell. We type exit to get rid of that shell, and we start a new shell. And you must remember to do this, otherwise it won't work. So PowerShell again, and now we should have access to UV. And so we can type UV minus version, and there we have UV installed on the machine. Now I'm going to show you this next part within Cursor. Here is Cursor. I actually quit Cursor and reopened it again for the same reason that we did that with a PowerShell, to reset the path variables. And within Cursor, I'm going to go to the View menu and choose Terminal. It's also Control and the back tick to bring up a new PowerShell within Cursor, which is a useful thing to do, and that's how we'll do it mostly on this course. And within here, if I do a dir, you'll see, or an ls, you'll see the contents of that directory. And I'm now just simply going to do the command uv sync, which is my way of telling UV that I want to build an environment consistent with what I have in this directory. And I do that, and what we're seeing now is it's building the environment, and it's actually beginning by installing Python, a dedicated version of Python 3.12, which is the version for this project, and it's now installing the packages. Now, people who are familiar with Anaconda know that this process of building a full-spec isolated environment with the right version of Python is something that can take up to an hour, and sometimes on some systems it was taking an hour and a half to build this environment on their computers. What you'll find is that it's a different story with UV. It's running remarkably quickly, and I'm hoping it's going to finish by the time I finish this sentence. But if not, then I may put you on pause and come right back again, because it literally takes a minute or two and it will be done. So I'll see you in a minute. Okay, so it did take about another 3 minutes, but I didn't lie. It's quick. It's very quick, and it's very impressive. And the big news is that that's it. There isn't any more of the kind of configuration management part. Those packages have been installed. If I look in this directory, you'll see that there is in fact going to be a new folder .venv. It's created a virtual environment for people that know about Python virtual environments. It's built one, and that now exists in this folder, and that's all there is to it. And going forwards, if we want to run a Python script, whereas you might normally type like Python and then the name of a Python script, you now would type UV run and then the name of the script, and it will automatically run it in that environment. And everything else is the same. The environment is built. It's as simple as that. We're pretty much good to go. And we're now in the end game. We're at step 4 of the instructions, and it's smooth sailing from here. The next step is to set up a key with OpenAI so that you can use OpenAI directly. If you already have a key, you can just skip this step. If you don't want to be spending money on OpenAI, there are alternatives. As I say, you will find them in the setup instructions, in the README, and in the linked in the guides. So please do follow those instructions. But I do assume that most people are okay to spend a few dollars, and it is quite cheap, on using OpenAI because the power of these frontier models is going to allow us to do great things. And of course, you can use DeepSeek or Google's Gemini or Grok as a straight replacement for any of these. Okay, so I go to a browser and I go to platform.openai.com, which is where you get into the sort of API side of OpenAI. And the first thing that you may need to do is sign up. I have already got an account, so I can just log in, but you may need to come in and sign up. If I log in, I can come in with my Google credentials. And here I am logged in as me to the OpenAI developer platform. Now, there are now two things that you need to do. One of them is about setting up billing, and one of them is getting an API key, and we'll do them both now. Okay, and so in order to set up your billing, you go to the settings menu up here, and then you go down to billing right here. And this is where you choose to put in a credit balance. You can see I've got quite a large credit balance. I seem to spend quite a lot of money on different projects with OpenAI, but this course will only cost you a few dollars. But the way that it works is that you do need to put in an amount up front, and $5 as of today is their minimum. So you'll need to put in that $5 and then you spend against it. For people internationally, I know that sometimes OpenAI can be a bore about charging because they charge in dollars, and some credit cards don't accept an international charge like that. So there is some nonsense to get around with that. And as I say, there's alternatives like DeepSeek if you want it. Some students use Grok with a Q, which there's also a great option. And you can also use something called OpenRouter that's quite popular, particularly with international students, because you can set up an OpenRouter account and it will route through to the different models. So these are all different approaches for you, and they work almost exactly the same way. There'll be some sort of billing page like this where you get to choose to top up, and you press add to credit balance to top up with a credit card, and you put in the minimum $5. We won't need any more than that for sure. Okay, and so once you've done that, you then have to go to the API keys section. And this is super important. And this is where you get to set keys that will be the how you will access this API from your computer. And the way that you'll do that is you'll press create new secret key. You'll put in any name you want, you can call it, just to remember it in the future. Make sure that you, for select project, you have default project, so it's for everything, have all permissions, and then press create secret key, and you will get a new key, and you can copy it into your clipboard, and you have to do that to make sure that you preserve it, because we're about to make use of that API key. Now, here's a pro tip to be really careful about. When you copy that key into the clipboard, you might be tempted to paste it into another application, like a notepad, that you will then copy and paste it somewhere else. But there's a trap there. Sometimes these kinds of word processors, when you paste in the key, they'll mess around with it in some way. They'll replace hyphens with long hyphens because they look better in text. And they may replace some characters with international characters that are right for your locale. And if they do that, your key won't work, and it's going to take you ages to figure out what's happened. So be careful of that. Don't do that. I suggest copying it to the clipboard and then immediately doing the next step we're going to do, which is actually using it in our project. So keep that trap in mind. If you do want to paste it somewhere to keep it for your records, then be careful to paste it into a kind of tool that's not going to mess around with the API key. All right, I hope that makes sense. I hope you've now created your API key if you don't have one already, and you've got it, and you've got it nice and safe, and you've recorded it somewhere where it's not messing with the characters, and we're ready to put this to good use. And this is it. We've reached the final step of setting up. Thank goodness. We're back in Cursor, and I pressed X on the PowerShell that was here, so we've got a nice clean screen here. On the left, this is the Explorer. I've collapsed all of these so that you just see the top level Explorer. And what I'm now going to do is right click here and say new file. And I've now got a new file I'm creating at the top level. Make sure that it's at that top level. And I'm going to call it something very specific. And you have to call this file exactly the same thing. And that thing begins with a dot, a period, full stop, as we say in England, and then the letters E and N and V. So it's called .env, and it has to be called exactly that for a very particular reason that we'll get to later. But as long as you've called it .env and nothing else, then you're in great shape. So that is the name of this file. A .env file is a common way that people put in environment variables that they want to set just for the purpose of this project. And there will be environment variables that will contain what we sometimes call secrets, or things that we don't want to be public. We don't want it to be checked into source code. We want it to be something that is just for us, kept private, that we will use. And we can just put things in this file of the form of like a key name equals and a value, and that will become an environment variable, as you will see. And in particular, there's one key that we really care about, and you have to do this exactly right. If you make a typo in this, then it's not going to work, and it's going to be really frustrating. So try to be really careful with this. I'm going to type open, and you can see that already the cursor is already, it knows what I want to do. See how it's filling it in for me? I could just press tab to do what it wants, but I'm not going to press tab, as you will see, because it's got a dummy key in there, not the key that we want. OpenAI underscore API underscore key equals, and you can see it's prompting me there, SK dash PROJ dash and a number. Now, what I want to put in here is something that will indeed start SK PROJ, and it will have a number, but it's going to be a long number, and it's going to be the thing that I just copied into my clipboard from the previous screen from OpenAI. You need to now paste that key right here, and it's got to look just right. It's got to start skproj and then be followed by that long number and letters, and it's got to have those hyphens in them just as they are. And this is, of the people that struggle with environment setup, most of the problems end up just being this one tiny step. So please get it right. So hopefully you've done that and you've put that in there and it's got a key in there. Now, if you're using other platforms like DeepSeek, then this is exactly what you will do. The same thing. You'll just put in here DeepSeek, and it will, there we go. It fills it in for me. DeepSeek API key equals. And you might have something else. You might be using Grok, the inference platform, or OpenRouter, or any of the others. Any keys that you've got, you simply put them in here like that, and we will use them later. So with any luck, you've put in OpenAI API key equals, and it's got your real key in there, which means that the setup is complete. Many congratulations. That's the painful part over, as long as it all works. We'll find out. Please skip the next video, which is going to be for the Mac people, the next lecture, and then we will reconvene after that. And I'm so excited to get started. Well, hello, Mac people and Linux people. Welcome to your setup video series. If you're a PC user, then what are you doing here? We just set up your environment. You're set. Go on to the next lecture. All right, Mac people. I had a rough time with the PC lot. I am. This is my sweet spot. I'm a Mac user, so this hopefully is going to be very easy and fun. All right, so I'm in a Finder window here, and I've gone into Utilities, Applications, Utilities, to show you that that's where you can find Terminal, to open up a terminal if you're not familiar with that. But I'm going to now assume that you know about this and open up a terminal. Here's one right here, and make that a bit bigger for you. Hang on. So this is where we are going to do some of the next few steps. And we've actually got a 5-step process for setting up your environment. And this is the first step, which is about cloning the repo, or getting a copy of the code for the class onto your local box. Now, I'm in my home directory here. If I do pwd, if you're not familiar with the command prompt, I've included a guide to get you more comfortable, more confident using the command line. It's common for people to have a directory called projects in their home directory, where they put all of their work projects. And if you have that, then if you do cd projects, it will go in there. Now it looks like I don't have one, so I have to make one with make directory projects and then change to projects. And now I'm in my empty projects directory, but you may have a few projects in there. So the next step is now to bring the GitHub repo here. And so what we now do is we go using our favorite browser to a page where we have the repo, which is linked in the course materials. This is what the repo looks like when you go to GitHub to myname/agents. And you see the repo here. Here are all of the directories, one for each of the weeks that we have coming up ahead of us, and then some general stuff. And if you scroll down, you see something that's known as the project README. And it's really important because it's got great stuff in there. And I urge you to read the README and the things it links to. It begins with some stuff which includes another appeal to LinkedIn with me. I seem to be quite desperate on this front. And then comes the setup instructions. And there's a link for Windows instructions for the other guys. There's a link for Mac and Linux. Come follow that link to get step-by-step instructions. And to be honest, those instructions are going to be way clearer than this video, and I'm going to keep them updated when people have problems. So that should really be your first place to go. And this video, see it as like a video that goes along through it so you get a sense for it. But the README also has lots of useful resources and a ton of important stuff on API costs that I urge you to read because I know this is a sensitive topic. And so please do look through it and read all the other stuff and the links to the guides and so on. And I should probably mention that if you've not used GitHub before, you might need to create a new account with GitHub to get to this point. Now, just before we clone this repo locally, I'd like to go back to the terminal window and I just want you to type git --version to check that you've got Git installed on your Mac. And it should come up like mine does with a version number. If it doesn't, you might need to run this command, xcode select ---- install, which installs some of the basic developer tools on your Mac. I've got a link to that in the setup instructions. I won't do it since I already have Xcode and developer tools installed. Okay, so with that, if you're typing git ---- version, you're getting a number there. You come to the repo, you've signed in to GitHub. There's this green code button on the top right, and you press there. And probably I recommend that at this point you select the HTTPS version. I'm going to pick this version because I have that kind of credential, but you can also pick the other one. And then you copy that into your clipboard by pressing the copy button right there. So once you've copied this text, which is the link to this repo, you then come back to the command line and in your projects directory, there I am, I'm inside users ed projects. I'm now going to type git clone and then the repo link that I've pasted from my clipboard and I press enter and in it comes and it's done. If I now have a look, you'll see that there is a directory called agents. If I go into agents, I now see that I have directories for the full project. And I want to mention that where we are right now in this directory that's in my projects directory, the agents directory, this is known as the project root directory. If you're inside the sort of top level directory of your project of agents. So this is the project root and you'll hear that referred to during the course and generally. And so it's worth knowing that that's what it is. But that is step 1 of the setup complete. Okay, welcome to step 2 of the setup for Mac. We're going to now install Cursor, the AI IDE, which is great. It is fabulous and you're going to love it. If you've already got Cursor, then of course you could skip this step. Otherwise, bring up your favorite browser and go to cursor.com. And here we have the screen for installing Cursor. You will need to begin by creating an account using the sign up button over here if you don't have one already, and it will just guide you through. I used my Google credentials myself and I selected a trial pro plan myself, which is free, at least for now. And I then press download for Mac, which then brings down an installer. I then run that installer and it then asks me a couple of questions. I log in and then it installs it. I mean, I'm sure you are used to these things. You then drag and drop into applications and you open that up and it will install it. Easy peasy. I selected all of the default setup instructions, nothing special at all. And then you should launch it and you should be in Cursor. And that is where we will go next. Okay, so once you've opened up Cursor, freshly installed, this is what it should look like, a nice big empty screen. And we're going to press the Open Project button right here. And we're going to then navigate to Projects, wherever that is. I guess it's going to be at the top, Projects, and then Agents, which is the new folder that we've just installed. This is known as the project root folder. Here it is. And then we're going to press open. And Here it is. Cursor opens up. We've got a nice screen here that's known as the Explorer, which shows all of the files organized by directories. One of these directories might be open. You can just click the swizzly to collapse it like that. There might be a box up here with some sort of welcome to Cursor, blah, blah, blah. Just X out of that extra box on the top left if it's there for you. Over here is a chat screen where you can chat with an AI about your code. And I'm going to suggest for now we X out of that as well to keep things really clean. So what we're looking at now is a nice big area here and the code, the Explorer to look at our directories right here, including the README and so on. And congratulations, you are into Cursor. And that is the second step of the instructions completed. And we are now on to step 3 of the instructions, which is my very favorite step. We are going to install UV, the package manager, which is so fabulous, so quick and easy to use. And you're going to be really happy about this. I know it's like another new thing to learn, which is always a pain, but I tell you, it's so great. The reason we're doing this is partly because a student on my prior course said, you know, you really should use UV. It's so much better. And so I'd heard of it. I knew it was doing the rounds, but I hadn't actually used it myself until that. And that pushed me to do it. And I've never looked back. And we'll find that many of the AI platforms, the agent platforms will use UV themselves. So it's going to work out really well for us. You're going to be grateful I showed you this if you're not already a UV convert. All right. So first step is to install UV. And the way you do that is you bring up a browser window and you can just Google for UV package manager, or you can look at the link that I'll have in the instructions and you'll see that there is the link to the GitHub and it has within it some clear installation instructions. You just simply have to run this one command in a terminal. And I will copy that to the clipboard. There it is. Now, there's actually a new easy way to run things in a terminal because you can do it within Cursor. Here's my Cursor screen again, and there's actually a view menu, and you can go view and then terminal, or you can know to press the control button, not the command button, not the one with the squiggle clover on it, but the control button on the bottom left of your keyboard, control and then the tick mark on the top left of your keyboard, or at least on my keyboard, and up comes a terminal. But you could also go to the view menu and choose terminal, and here it is. And now you can simply paste in that command to run the installation for UV, and it will be super quick and you'll be done. I'm not going to run it because I've already run it. Once you've done that, you might need to close this terminal by pressing the X, and you might actually need to quit out of right out of Cursor and bring back up Cursor because it needs to refresh its environment variables. But if you've done that, then if you type UV ---- version, it should give you a version number which is telling you that all is good, UV is installed. And with that, we are almost ready to go. There is now only one command left. And what is that command, I hear you ask? It is simply to type at this point UV sync. Like that. And what that's going to do is it's going to look at some of the other files here, like a Python version file and a pyproject.toml and some other things and a UV lock. And it's going to use that to build our environment. And let's see it doing that. Off it goes. Now, I told you that it's quick, and you'll see that it was very quick. That is just done. But that's actually quicker than it will be for you. And it's that quick because it does cache things that I've done before. When you do this, it's going to take about 3 minutes, 4 minutes, which is still very quick because Anaconda takes like an hour or something. So it's going to be fast, but there is still a lot to be installed. So you'll have to sit back and wait while everything installs, but enjoy the raw power of UV as everything gets built there. And once it's done, what you may notice is that there's a new directory called .venv that's appeared, which is like a traditional Python virtual environment, if you know these things, so that it's created one for this project. And so one of the really nice things about UV is that it's compatible and consistent with all of the other ways you do things in Python. It's not like there's a new sort of thing like Conda. So that's been set up. And now that is going to be the environment that we'll be using from this point onwards. And when you run a Python script, whereas before you might have typed Python and then something, what you're going to type now is UV run and then that same thing. And that automatically makes sure that it runs in that environment. The other thing to mention is that it has installed a dedicated version of Python right for this project. It is, in fact, a Python version 3.12, whilst the latest version of Python is 3.13. That's not yet, not all data science packages are ready for that yet. So 3.12 is what we're using, and everything will be in that Python. It will have installed it for you if you didn't already have it, and it will be dedicated for this project. UV is really good. It combines this kind of isolated environment with something that is fast and simple. And I very much hope that this will have simply worked for you. And that means that step 3 is done and we can move on to step 4. So for step 4, we're going to set up a key with OpenAI. Now, again, I want to emphasize that whilst I do encourage you to be setting up a key with OpenAI and to be using that API, it is not required for this project, for this course, and there are alternatives in the README. But that's what we're going to do now. I'm going to assume that you are good for this and that we can come in. And so you go to platform.openai.com, just here like that. And this brings you to the front screen of OpenAI, where you get to set up an account if you don't have one already, sign up, or log in if you have one. And I'm going to log in because I already have one, log in with my Google credentials, and here we have my account. We're logged in, and you will hopefully have done the same. Let me make this nice and big for you. Okay, so there are now 2 things that we have to do now that we're in OpenAI, and we're going to go and do both of them now. Bearing in mind that this is not required, you can also do the same thing. There's an analogous website for DeepSeek and for many others. You could be setting up your keys in any of them and just follow the same kind of process. But let's get to that now. So as I say, it's 2 steps. The first of them is to go to the settings menu up here and come down to billing. And this is where you set up your billing details. Now you have to apply a credit balance, giving OpenAI some money in advance. And I've given it quite a lot of money right here because I'm doing various different things, and you do not need to give it that much money by any means. There is a minimum top up. They require at least $5 as of right now, but they are, they sometimes have deals. There's something going on down here that you could read about. Perhaps there's some deal for free tokens right now, but there's different deals, and you can press the add to credit balance to put in your $5 up front. That's I believe required right now. And we'll only spend a few dollars of that on this course, and you have complete flexibility, and you can come back and watch to what extent you're spending your credits as we go through. But I suggest doing that, putting in your $5, but bear in mind, if you don't want to, you don't need to. Once you've done that, you then turn to the API keys part of this, which is where you get to see the key that you've set up that you will use for this project. And if you already have a key, then great, you're in good shape. But I assume you don't, in which case you press this green create new secret key. You leave, you give it a name that this doesn't matter, just for your future reference. And then for project, be sure to choose default project and leave it as all permissions, and then press create secret key. It's then going to prompt you. It's going to bring up your key that you'll use, and you can copy it into your clipboard. And we're going to paste it in a moment into Cursor in a place where we were going to use it. Now, here's the thing. Here is a nasty gotcha to be aware of. It's very tempting to take your key and paste it into a useful app like the Notepad or something. But there's a trap there you need to be careful of. Some programs, I think including Notepad, if you paste in some text and then press enter, it changes some of the characters in that text to be nicer formatted. Like it turns hyphens into long hyphens. And that can be really hard to spot. And that will then basically invalidate your key. Your key will now be a different set of letters or characters. And when you try and use that in your file, it's going to fail. And it's going to be almost impossible to track it down because it's going to look perfect. And it's really frustrating. And a lot of people have had that problem. So I urge you just to copy it into the clipboard and paste it straight into Cursor at the next step. And it is good to keep a copy of it somewhere. Just be really careful to make sure you do it in a way that doesn't overwrite your characters so that you're keeping the original and it feels in good shape. So there is my public service announcement about things to watch out for with keys. But hopefully you've set up your key, you've copied it to the clipboard, you've maybe made a backup somewhere safe, and now we're ready for the next part. And this is step 5 of the environment setup. And as the last step, we're almost completely done. We're back in cursor again, looking at cursor. And I'm going to press an X here to get rid of that screen. I'm going to press an X to get rid of my terminal. So we're looking at a nice clean page here. Now, down here in the Explorer, I've collapsed all these folders. I'm going to right click and say new file at the bottom here. And I'm going to create a new file, and I'm going to give it a very precise name, and you have to give it exactly the same name. If you get this wrong by a single character, then you're going to have problems later. So be careful with this one. It starts with a dot, a period, a full stop, and then the letters env, .env, and it's got to be called exactly that. And you'll see why later, but basically this is a file which is often used to store environment variables, things that will load into our environment as variables that we'll use for things like passwords and tokens and keys. And it doesn't get checked into GitHub, so it stays as a private file just for you. And it's a common technique for managing these kinds of things. And it's called .env, and it has to be called exactly that. So what we can now do is type into here a key that we want to remember. And in particular, the one that we want to remember is OpenAI's key. And it's OpenAI _API _key. And it's actually prompting me right here for it because Cursor's that clever and knows what we're trying to do. And we can just press tab to fill it all the way in. But I'm not going to do that. I am going to type OpenAI API key equals, no quote marks, no spaces before or after. And people, one common mistake is that sometimes people say open API key or open AI key, but it's not that. It's OpenAI API key, and it's got to be exactly this. I think this is one of the only things in this course where every letter needs to be right. And so be careful. This is like 90% of the reason that people are frustrated in environment setup is this very file. All right, what comes next is you simply paste in here exactly the key that came from OpenAI, and it should begin sk-proj- and then a bunch of letters and numbers with maybe an underscore symbol as well. And that should all come there, a bunch of them, not 1, 2, 3, 4, 5, 6, 7, 8, 0 as it has here in Cursor, but a real key, and not sk-proj and then another sk-proj or anything like that some people have done. It's got to be just right. Sorry to go on about it, but this is such a cause of problems. So make sure that key, the thing that's showing in purple here, is exactly the key that you took from OpenAI, and it should look perfect. And once you've done that, you do like Command S to save this file, and you'll be in great shape. And at that point, that will then be the end of step 5 of the environment setup. We will have done environment setup, and we're good to get into the actual project. How about that? So congratulations. Thank you. Hopefully this is now all going to work. We'll soon find out. I will see you in the next lecture when we reconvene with Team PC. Welcome back, everybody. The Mac, PC, Linux people reunite for our video where we now start to work with our project. Your environment is set up. You should be looking at Cursor, looking nice and clean like this. X out of any windows that are open. Have it look a bit like me. And then on the left here, you've got the directories. The first one up here, 1 Foundations, represents the directory for week 1, where we are right now. We open that up, and I'd like you to click on Lab 1 that comes up right here. At the top here is a little section that tells you about the setup folder, which has all of the setup guide that by this point you should have already covered it all, so it should be fine. And then the guides folder has a bunch of useful guides. It has some stuff to take you through intermediate level Python. And it also has beginner Python. If you're new to Python coding, then it will take you through some self-study guides there. If you're willing to do that, I think it will need some time investment, it will be well worth it. And then for intermediate level Python, there's important stuff there too. There's a bunch of stuff. One of the things that comes up a lot in agents is working with async code. There's async stuff in there. There's also going to be things about generators, which are very important, and a lot of good intermediate level Python material in there. If you're also not as experienced with coding, there's going to be stuff about debugging, how to go about debugging. If you get something called a name error, that's something which has always got a way to work at a name error. So there's good details on that too. So please do look at the guides. I put tons of stuff in there. There's also a troubleshooting guide. If things go wrong, troubleshooting takes you through every step, including some great diagnostics at the end. And then this next little comment here is saying that these labs, think of it a bit like it's like an ebook. It's got content and information as well as things to try. And what you'll find is that what you'll see as we go through this may be different. What you have may look different to what I go through right now. And you may say, well, that's annoying. I wish it was all the same. But here's the thing. The reason is because I like to keep adding more stuff, make it current. I try and make it very clear when it's something new that I've added. I bring in extra information to keep it up to date. And when people struggle and they hit problems or they need something explained better, I can put that in there. And that means that everyone benefits from where some people have struggled or I haven't explained something well. I can add it in there. So for me, it's super important to do that. And the reason I don't come back and record all the videos as I do it, well, first of all, that would take a lot of time. And I'd rather spend time getting this up to date. But also because that would erase some of the progress that people have made with videos they've watched. And it can be quite jarring if you're in the middle of a series and then the videos are changing under you. So it's really worked out better for me to keep these labs up to date as much as I can. So treat the labs like a resource. And the way that I suggest that you work with me is watch the video of me going through a lab. I'll go through it, I'll explain it, I'll execute things. I wouldn't necessarily suggest that you do it at the same time as me because that's not really the point. The point is as soon as I've done a lab, you come back and you go through it step by step yourself and you use that as a way to build the learning, add in print statements and so on. Okay, a couple more things to say on this. I'm using here things called notebooks, which are a particular type of Python code that's organized in this way into cells. And there's a guide on how to use notebooks like this if you're not familiar with them. And I know that a lot of people from an engineering background initially get a bit frustrated like this because they'd rather work with just Python code. We will work with Python code as well. We're going to use both. But this kind of notebook has its place. It's very useful for research and development, which is an important part of being an AI engineer. And it's also great for learning because you can run things step by step, experiment, tweak, put in print statements and learn. And so there is a benefit to this too. So even if you're not used to these kinds of notebooks, I promise you there's good stuff here too. And we will also do some Python coding using normal modules. All right. That's the end of all of the details. Let's get to running this first lab. Okay, the first step is to go to the top right, just here where you see select kernel. You click there and you have to choose your Python environment. And the way you do that is you type Python environments right here. And this first one up here with the star that says .vmv, it says recommended, and it's right in this directory. That is the one you want to pick. And hopefully that's going to come up really clear for you as Python 3.12.vemv at the top. And once you've done that, it will be set up here. And you'll always, when you come to a new lab, you'll need to do that. And so do bear that in mind for it to work. Okay. And then as like a final little thing here, it's I got one more link to my LinkedIn in case you haven't succumbed by this point. Remember that you can always LinkedIn with me. All right. So now what we do is we come here to the first of these cells. Each of these things are called cells, these code cells, and we're going to do an import. And what import are we going to do? Well, we're going to do this import here from .env. And you can see that cursor's already suggesting what we could do right now. From .env, import load.env. And I hope you're familiar with what it means to import a function from a module, but if not, then please do check out the guides for a refresher on that. But I'm now going to run this code cell by simply pressing Shift, followed by return or enter, and that executes the cell and it's done. So the next thing we're going to do is use that function, and this is how we do it. We say load.env, and I'm getting prompted already. There it is, load.env override equals true. So what does this do? Load.env is just a utility function which does something very specific. It looks for a file with a very particular name in your project root directory. And that file name happens to be, as you probably guessed, the name .env. And it's assuming that that is where you're setting some of the environment variables that you want to use for this project. And it's just a utility that looks at that file, interprets it, and sets environment variables as a result. That's all it does. And override is true is just a nice little trick to know about. By default, load.env, if you've already got an environment variable set, perhaps with your profile, then that takes priority and it won't overwrite it. And that can be a nasty little gotcha, because if in the past you've set up an OpenAI API key and you've stored it somewhere global on your computer, that would take priority and you wouldn't be able to figure out why on earth OpenAI is rejecting your key. And so it turns out that this, as you can imagine, was a common problem in the past. And I have learned to tell people to always put override equals true, which means that what's in the .env file takes priority. And we run this by pressing Shift Enter, and now our environment variables will be set. So let's check that. This next cell does an import OS, and then we look for an environment variable that's called OpenAI API key, which is exactly what we named it in the .env file. And if it exists, we're going to print it exists and it begins and give the first few letters. Otherwise, it's going to say it's not set. Please go to the troubleshooting guide. I press Shift and Enter to run this, and there we go. The OpenAI key exists. It begins, skproj. All is good, and I hope all is good for you too. If not, go to the troubleshooting guide. Okay, and now we have a super important import statement, and it looks like this. From OpenAI, import OpenAI. So if that seems weird to you, why is one in lowercase and one not? Anything like that, again, go to the guides. They'll explain the difference between classes and modules and all the rest. But we are now going to execute this. And if this gives you any problems at all, then that might suggest a problem with your UV environment. Troubleshooting guide, and always contact me if you get stuck in any way. I'm here to unstick you. All right. So what we're now going to do is create an instance of this class. Now, I tend to always do it this way, OpenAI equals OpenAI. And that can be a bit confusing to people because, again, we're using like the same word, OpenAI. The proper way to call this would be something like OpenAI Python client. Because what we're doing is creating an instance of the Python client library. But I just call that OpenAI because it's just simpler and shorter. But that's what it stands for. We're creating an instance of that class, and let's run that right now. And it's worth bearing in mind that some people think that when you do this, you're creating something to do with the actual like GPT large language model locally, but you're not. OpenAI is a lightweight library for connecting to OpenAI's endpoints on the cloud. So this is just what people sometimes call a client library. It's just a simple wrapper library around endpoints that calls HTTP endpoints to call the API that's running in the cloud. And that's all it is. It's a simple, lightweight class for that purpose only. So with that, let's keep going. What we're now going to do is create a list called messages. And this is a format that I hope most of you are very familiar with. On my LLM engineering course, we do this one to death. And if you're not, I'll try and put some extra stuff in the guides. I'm not going to explain too much of it right now, but conversations with large language models are often represented in this format that OpenAI invented and has become ubiquitous everywhere. Lists of dictionaries where each dictionary has a role and a content. In this case, we say the role is user, the content is this simple question, what is 2 + 2? So we run that. And now we're going to actually make a call to OpenAI and check everything is working. Okay, and so now we're going to come here and type the code to call OpenAI, and Cursor is going to make this very easy for us. We're just going to type response equals OpenAI dot, and it's chat .completions.create, and you can see that Cursor's already filling that in for us. I can just press tab and it's going to complete that right away, and it's going to say the model is GPT-4o mini and the messages are messages. That's perfect. And it's also going to take the response, take the first choice, .message.content, and print it. And that's exactly what we want to do. This structure of calling OpenAI is something that is so common these days. If you're new to it, then take a look and I'll try and cover some in the guides. But people who are familiar with this will see this is a very simple way to call OpenAI. And if we run this, we get the response to the question, what is 2 plus 2? We get 2 plus 2 equals 4. So we know we are connected to OpenAI, and so far, so good. So hopefully you're now comfortable that we can both call OpenAI, we can get responses, we can use the very standard chat completions API structure, and Cursor will fill it in for us if we ever forget what it is. But now let's ask a harder question. It's time for us to be a little bit agentic. We're going to put one foot in the agent camp. It's more a workflow than an agentic AI, but still, it's getting there. We're going to ask a question. Please propose a hard, challenging question to assess someone's IQ. Respond only with the question. So that's going to be our question, and we're going to put that into the standard messages structure. And now we're going to ask it. So again, we say response, and it's already filling it in for us. We press tab to complete that. We press tab, but we're just going to change this slightly. We're going to make this reply equals. Maybe I should make this like question equals. So we're going to take back what comes back and we're going to make it question, and then we'll just print the question. Again, Cursor fills that in. Let's run that. And here we go. Here we have a question from OpenAI. If a train leaves a station traveling at 60 miles an hour, another train leaves a different station 120 miles away, the same time traveling 90, how far from the first station will the two trains meet? A nice brain teaser right there. So what we're going to do now is we're going to take this question and we're going to make a second call to an LLM to answer the question. And that's why I describe this as an agentic pattern, because it is making multiple calls. We are orchestrating multiple calls to LLMs to solve a bigger problem. And so it's going to be relatively easy. We're simply going to continue this by, again, making another messages. Look at how Cursor fills that in for us. Messages where the role is a user and the content is that question. Great, let's run that. That is now messages. And now we're going to ask OpenAI again. So we're going to say response is openai.chat.completions.create. And again, Cursor fills it all in, and it fills in the answer. And it's even clever enough to recommend that we call it answer instead of question. Honestly, it's incredible. So this is exactly what we want to do. We're making the same kind of call to OpenAI's chat completions API, the simplest way to call OpenAI in the cloud. And we are now getting back the answer to the question, and we will print that answer. And I believe the answer we're looking for is 48, I think. Let's see. So we'll get that to print. And here we go. A bunch of information right here, written with 48 at the end there. And you may know this already. You recognize that this has come back in a form of Markdown. It's got some Markdown stuff in it, which LLMs love to talk in Markdown. We can just add in a little code in here, and we can do from it's spooky. It is spooky the way Cursor does this sometimes. From ipython.display, import markdown and display, and then the next line that Cursor is telling us to write. I don't really need to have a job here, do I? Display markdown, but the only thing it's got wrong, thank goodness it got something wrong, is that what we actually want to display is the answer, not the question. So if we do that and we run this, then we see the answer formatted nicely. I'll let you read through its work, and it comes up with the conclusion of 48 miles. So there we go. That is our first semi-agentic pattern built just in a few minutes. If any of that was unfamiliar to you, check out the guides, play with it, look at it. And as I say, congratulations on getting here. But at the end of this lab, there is an exercise, and I do encourage you to do the exercises. This is where you really get to show that you've done this. You may be thinking, okay, there wasn't much commercial about this project, and I do like to try and weave commercial angles in wherever I can to make this applicable to business. And so I've got an exercise for you to now make this applicable slightly to business. So we are going to try and ask an LLM, first of all, to pick a business area that might be worth exploring for an agentic AI opportunity. Secondly, to identify a pain point in that business sector that it's decided on. And then that's one that it needs to explicitly explain what is that challenge that might be ripe for an agentic solution. And then the third step will be to actually propose an agentic AI solution to that problem. So I would like you in this empty cell here, probably assisted by Cursor, to go through and make this happen with 3 calls to LLMs. First of all, you put something in this message to explain that you want it to pick a business sector. Then you get back the response. Based on that response, you read in the business idea, and then you will repeat these 3 steps in order to get the pain point and then to get the agentic AI solution, and print them all out, print them in Markdown if you wish, in nicely formatted, and use that as a way both to experiment with some agentic workflows and also actually to get some commercial benefit, to get perhaps an interesting idea about a way that you can apply agentic AI to a real business pain point. All right. I hope you enjoy that challenge. If you have any problems with it, of course, then you can either get help from ChatGPT or Cursor, or just drop me a note, and I will see you for the final lecture for this first day. Well, hopefully at this point, you've now brought up that lab, you've gone through it yourself, you've put in some print statements, you've understood what's going on, and you've used it as your way to then complete the exercise, both to try this out yourself, make a few different calls, and you've also got some commercial feedback as a result. And, you know, it's not only about an agentic workflow that takes several steps. In a way, we've also given our LLM some autonomy because we asked it to come up with the business sector that it would investigate. And so you could think of that as, again, a baby step towards allowing the LLM to plot its own path, to choose its own adventure, which, as we'll see, is one of the hallmarks of an agentic AI solution. Okay. So this hopefully looks a bit familiar to you. This is the 6-week curriculum that I showed you before. That is how we are laying on information week by week. And we are now wrapping up the first day. And you're thinking, wow, this was a long time. I will tell you that this day there was a lot of setup stuff. Other days will be shorter and we'll make a brisker progress with good commercial stuff right away. But what I'm going to do is highlight in that square on the bottom left to show making an agentic workflow. Your first workflow is done. We've made progress already. Next time, we're going to be talking about agents and agentic patterns and introducing what they are and how they work. And I can't wait. I will see you then. Well, if you're watching this video, then you weren't entirely put off by the grueling day 1, and you've come back for more for day 2. Welcome back. So this is going to be an interesting day. It's going to be different to day 1. It's going to be shorter than day 1. You'll be happy to hear. But also it's going to be pure theory. We're going to be talking about agents and agent architecture. Almost all of the days on this entire 6 weeks program are very practical heavy. This is one of the rare days that is going to be a theory day, but it's going to be interesting. It's going to be really great. I'm going to tell you all about agentic architecture. Let's get to it. So where better place to start than with the almost obligatory, what is an agent kind of question? And the interesting thing is that there's not actually a great answer to that. Agentic AI is one of these things that's been super hyped and generated a lot of excitement, and people are using the term to mean a lot of different things. And in fact, there was a meme going around last year about how agentic AI could mean almost anything. But having said that, typically, there is one simple definition. And actually, the definition that I'm pulling has come from Hugging Face, their small agents project, where they give a really nice, crisp, simple definition. And they say AI agents are programs where LLM outputs control the workflow. So basically, one output from LLM is able to decide what tasks are carried out in what sequence. So that is a good, crisp definition. It's something for you to keep in mind, and it applies in some situations and not in others. More generally, though, you will find that there are different hallmarks of what makes something an AI solution, and people will often use the term agentic AI or agents if any one of these 5 hallmarks are met. So first of all, sometimes any solution that involves multiple LLM calls could be called agentic AI. And, a bit like the one that we just built in day one, that could be called agentic AI. Now, this one, LLMs with the ability to use tools, that's often what people think of as the kind of litmus test for whether something is agentic. If you remember when we looked at the N8N idea in the very first, at the beginning of the first lecture, when I had it turn on the lights that I was wearing, that was an example of tool use. And we're going to be talking a lot more about tool use. So that's obviously a hallmark quality as well. Another is when you have an environment set up which allows different LLMs to send information to each other, a kind of coordination, orchestration environment. That in itself, for some people, defines agentic AI. Sometimes it's when you have a planner, some process that's able to coordinate activities, and that itself is an LLM. That is, and that's quite similar to the text in blue. That for some people is the hallmark of agentic AI. But for some people, for a lot of people, there's this word autonomy, and that really captures the essence of agentic AI. And this word is saying that we are giving some ability to an LLM to control what order things happen in or what happens, to sort of choose its own adventure in some way. And giving it that autonomy, giving it, if you will, that agency, is one of the ways to define agentic AI. And in some ways that sounds kind of spooky, like what does it mean to have an LLM, a statistical language model that is autonomous? And to be honest, it's just sort of fancy use of language. In many ways, you could argue that exactly the project that we just did, the challenge that I set you to have an LLM come up with a business sector that would then be analyzed for pain points. In some ways, it was showing autonomy there because it was able to choose what business sector to use. And even more straightforward was when we asked for a question and then we had it answer the question. It had a level of autonomy. So you can see how any time when we're giving an LLM the opportunity to decide how we will carry out future actions, you could think of that as giving it autonomy and that being a way to describe agentic AI. And just to go one level deeper, Anthropic wrote this brilliant post that's called Building Effective Agents. And I will refer back to that many times because I think it's just so clear and well written. And in that particular paper or that blog post, they distinguish two types of what they call agentic system. So this is their terminology, but they would say that there's this umbrella term, agentic system. And under that umbrella term, there are two different categories. And one category is called workflows. And these, as it says, are systems where models and tools are orchestrated through predefined paths. And they delineate between that and something called agents. And agents are where models dynamically direct their own processes and tools, maintaining the control over how tasks get accomplished. So these are the two different sort of subfields under agentic system. There are workflows and there are agents. And you can see they're sort of hinting that perhaps the things that a lot of people call agents are in fact workflows. So they're drawing that distinction, but they do still describe the whole thing as being agentic systems. So it's a bit of wordplay there. Does that mean that workflows are agentic or not? I guess they are, but you can see there's some ambiguity in the terminology, but I do think this is a helpful framework for distinguishing between these two worlds. And we're now going to go deeper. We're going to look at each of these and look at some common design patterns. And this should hopefully start to bring things to life and show you about how we can apply this kind of thinking to actual projects. Next, we're going to peel back the onion a little bit more on workflows, looking at different types of workflow. Anthropic identifies 5 different design patterns that you'll find when building agentic systems that have workflows in them. And let's go through each of them and talk about them. This is the first one. They call it prompt chaining, and it's a simple one. What you're seeing here in this diagram, obviously the in and the out on the left and the right is the beginning and the end of the workflow. The yellow boxes represent calls to models, to LLMs, and the blue boxes is where you potentially have just some code that you've written, some software, and it's optional. And what you'll see there is that this is simply saying you could have an LLM carry out some task, and then potentially, based on some code, you could then pass that to a second LLM, and that output could go to a third LLM, and that could be the conclusion. And actually, this is really similar to what you just did. This is similar to that commercial question when we ask an LLM first, pick a sector, and then given that sector, pick a pain point, and then pick a solution. And obviously, it doesn't need to be 3 LLMs. It can be as many as you want. But this is the idea. You are chaining a series of LLM calls, decomposing into a fixed set of subtasks. And the reason you might want to do that is because you can take care to frame each LLM call very precisely to get the best, the most effective LLM response based on that prompt. So it allows you to really work on each of those tasks being very effective, and then keep your whole process, your workflow on guardrails by taking it step by step through a sequence of well-defined tasks. Now, I want to make a point that you might have already thought of. Whilst Anthropic is quite clear to define this as a workflow and not an agent pattern, it is perfectly possible for prompt chaining workflow like this to be giving the LLM some discretion on what activities happen. Because just as we did in our example, the first call to the LLM might come up with a topic, and it's that topic that gets worked on by LLMs 2 and 3. So in some ways, the way that Anthropic distinguishes between workflows and agents, it's a little bit artificial. There is definitely a blurred line between them. It's perfectly possible for there to be an element of autonomy about a workflow pattern like this. Onwards, the second design pattern is called routing, and this is where an input comes in and an LLM has the task of deciding which of multiple possible models are selected to carry out this function. And the idea is that you might have specialist models. In here, they're shown by LLM 1, 2, and 3, and they're each good at different tasks. And the router's job is to classify the task, understand which of the specialists will be best equipped to tackle this task. And it allows for, as I say here, separation of concerns, for being able to have different LLMs that have different levels of expertise and have an LLM decide how to route to those experts. So this is a powerful model. It's very common, and it's something which, again, I would argue it's a bit artificial to say that there's no autonomy here, because clearly that router is able to make some decisions, albeit on guardrails. Again, it still has to follow a given workflow. And on to the third design pattern, parallelization, which is, at first blush might look quite similar to what we just talked about. There is a lot in common with these design patterns, but the idea here is that you have, remember the blue boxes represent code, our code, not an LLM. So we write some code that takes a task and breaks it down into multiple pieces that should all run in parallel. So in the previous design pattern, it was an LLM doing the routing, and it was one of these 3 experts that was given the task. In this design pattern, it's code. It's, let's say, Python code that's deciding what to do, how to coordinate. And in parallel, it's being sent to 3 LLMs to carry out 3 different activities concurrently. And then there's more code, maybe it's Python code, that takes those answers and stitches them together. And actually, Anthropic makes the point that these tasks don't necessarily need to be different tasks. You could imagine a situation where you send the same task and have it be done 3 times, and you use the aggregator perhaps to take the average or something like that. So there are various situations where this might be the same thing that you're doing 3 times. It doesn't need to be different, but I think most commonly it's when there are multiple subtasks happening concurrently. That is the parallelization, it's a hard word to say, of the design patterns. Okay, and now this one, orchestrator worker. This is when a difficult, challenging task is broken down and recombined. And you might be thinking, hang on, isn't that just what we just did? I just flicked between them. Don't these 2 slides, these 2 design patterns look really similar? Well, you'll notice a subtle color change along with a change in terminology. The key point is that this is exactly like the prior design pattern, except it's no longer code that's doing the orchestration. It's an LLM. So you are using a model to break down a complex task into smaller steps. And then you are using a model to combine the results. And so this is a much more dynamic kind of system where the orchestrator can choose how to divvy up the task. And again, I would argue that it's quite artificial to categorize this as a workflow rather than an agent pattern that we'll look at in a minute, because clearly that orchestrator has discretion over how it divvies up the tasks, and it could choose how many different LLMs get assigned the activity. So saying that this is just a fixed workflow is perhaps a stretch. So, I think you get the overall idea. There's certainly more constraints on this than when we come to the more flexible agent flows. But generally, the idea here, LLM breaks down the task, LLMs carry out each expert task, LLM synthesizes the task for an output. That is pattern 4, the orchestrator worker. And now onto pattern 5, the final workflow pattern, and the one that I use most commonly. This is one that I come against all the time. And it's called an evaluator optimizer by Anthropic. I tend to call them just evaluators or validation agents. You hear that a lot. But the idea is, it's very simple. You have an LLM that's doing your job. Let's call it the LLM generator. It's doing something and it comes up with a solution shown in this white arrow here. And you have a second LLM that's playing the role of evaluator. It's there to check the work of the first LLM, and it's given any extra information, any context, everything to arm itself to not be trying to generate content, but check the work of a prior LLM. And based on that, it can choose to either accept or reject the work. If it accepts it, then that's it, goes to the output. If it rejects it, it should come up with a reason, and the rejection and the reason goes back to the LLM generator, and that can then choose to come up with another solution, which comes back here. And so you can see this sort of feedback loop setup. It's very powerful. Of course, one of the key concerns of building production systems with LLMs is about accuracy, predictability, robustness of the responses. And having validation agents, having these kinds of evaluator optimizer flows in your LLM solutions is a really powerful way to increase the accuracy and build more guarantees. There's never full guarantees with LLMs, but build a higher level of guarantee around the quality of the final output. So this is a really effective pattern. I use it all the time. And of course, we'll have plenty of examples on the course, and you should be able to think about how you could apply this to LLM solutions in your day jobs right away. And so with this, we now turn to the other category, the second category of agents. So by contrast with the workflow patterns, with agents, the process is more open-ended. It's something that can keep going. It has feedback loops. It's typically a design that allows for information to come back and be processed multiple times. And importantly, there's no fixed path through the design pattern. It's not like there's a series of steps as we had in those prior patterns, but rather it's something that's fluid and dynamic. And as a result, it's something which can be much more powerful. There's a much greater kind of problem that could be taken on by this sort of agent pattern, but it's less predictable. And so there are absolutely concerns about robustness, about guardrails, about how do you get the best out of this kind of flexibility, but still have a system that can run in production and be guaranteed to complete in a certain time, and so on. And this is the diagram that I would bring up, which is a fairly generic kind of diagram that's just meant to show that you have the inputs and outputs now shown as a human, but we don't really have output anymore. We have environment that's meant to reflect some sort of outside world that can be interacted with, such as the lights that I wore around me. That the human can make a request that goes to an LLM. The LLM is able to take actions on the environment, as you can see, and the LLM is able to get back information from the environment in some way. And then this is simply a repeating loop. The LLM can continually make other actions and get back feedback. And at such time as it desires, it can choose to stop. And so this is the diagram, and there aren't more specific design patterns, because it is in itself this sort of open-ended design pattern. It's saying this is it's almost a sort of meta design. It's saying the LLM gets to choose its own design for how it's going to solve the problem. And that's really, it's quite hand wavy, but that's the way to distinguish it. If we look back at this pattern, I mean, this pattern arguably also could keep going forever. It's not as if this has a fixed stop, but there's clearly more certainty about what's happening for what reason than with the agentic patterns, where it is more fluid by its nature. So that's really the core idea behind the agent patterns, that there is much more flexibility that allows us to be able to solve much more complex problems where LLMs can really plot their own paths. But it does introduce some new issues, such as not knowing how long it will take before it will complete its task, not knowing whether it will complete its task at all, not knowing what kind of quality outputs we will get, and not knowing how much it will cost. These are all the kinds of challenges that agent developers like ourselves need to face. And they are the sorts of things that we will be tackling in the coming weeks. And so if this feels a bit unsatisfying, that the design patterns for workflows are so clear and now this looks just so loose, then all I can say is, as we put this into practice, as we code different real agent environments, this is going to become more and more concrete, and you're going to be able to, you'll see this as second nature before too long. Now, let's just quickly say a few more words about some of the drawbacks that I alluded to a second ago with using agent frameworks and agentic AI and design patterns. So obviously, there is this sense that you have an unpredictable path. You don't actually know what order tasks will take place in, or even what tasks will happen. You don't know what the output will be. There's no guarantees that you're going to get a great output. Now, this whole agentic architecture allows us to take on much bigger, harder problems than we've ever been able to take on before. But it does have this inherent uncertainty associated with giving LLMs autonomy over how they tackle problems. There's also unpredictable costs. I alluded to that as well a moment ago. But because you don't know how long it's going to take, you don't know how much it's going to cost in terms of running the APIs and potentially building up a big bill. And so, as a result, there's a couple of mitigations that are incredibly important, both of which we will spend plenty of time on in the coming weeks. One of them is, of course, monitoring, being sure that you have the kinds of visibility into what's going on behind the scenes, so you can understand what's going on with your models, with their interactions, particularly when you have potentially many agents all interacting. And we're going to see that with OpenAI SDK. We're going to see the trace, the ability to watch different agents interacting. When we look at LangGraph, we're going to see LangSmith, their tooling. So we're going to see a lot of the ways that you can have this visibility into what is going on under the hood in your agent systems. And then guardrails. Guardrails is the name for the kinds of protections that you can write in software that makes sure that your models are doing what they should be doing, or that they're not sort of leaving some constraints, some rails that you put in place. And in fact, that quote that I put here comes straight from the OpenAI Agents SDK, which has a ton of functionality dedicated to guardrails, and they say that it ensures they behave safely, consistently, and within the boundaries that you wish. And so we will be building those guardrails ourselves in week 2. And with that, that does actually conclude the day 2 lectures. As I promised you, it was shorter than day 1, and I hope you didn't mind that we covered a lot of theory. It's really interesting stuff, these agentic design patterns. I hope now you've got some clarity on what agents are, and that there is ambiguity on this, but ways that you can talk about it and think about what it means to be autonomous and what it means to be able to plot your own path. Let an LLM decide the path that things will take. And so with that, congratulations on completing day 2. In day 3, we're going to talk about orchestrating LLMs. It's going to be more coding, more hands-on, which will be fun. We're going to build with a lot of APIs and get ready for that. And after that, we're going to move on to tools. So I will see you next time. Well, hello, I'm back, and you're back too, which is a great thing. It means it's time for us to start day 3 of our journey together. And day 3, we've already done building an agentic workflow for the first time, and we've talked about patterns, and now we're going to talk about orchestrating between LLMs and many of them. So this is going to be a practical day. You'll be pleased to hear it's about time we got some more coding, and we're going to be calling a lot of LLMs. And I just want to, of course, say a few things up front. We're going to be calling both paid APIs and also open source models. And we're going to be calling them both in the cloud and also open source models locally, and doing it throughout this course. And I want to be clear that you have complete flexibility to decide which models you pick at which point. I'm going to have coded it one way, but a great exercise is to take what I've done and apply it to other models. And if you don't want to spend a dime, you don't need to. You can do this all using local models, although performance might vary. You can see the results I get from the models I use and try and see what you can achieve with free open source models as well. And if you want more information on what it's like to select models, whether they're open or closed source, apply them and deploy them, then you should take a look at my other course. We're not going to be covering that in detail here, because otherwise I feel like it's going to be too much of a rabbit hole and we'll get distracted. So I'm assuming you're coming into this knowing about the different kinds of models and having a sense of what makes sense for closed source, open source, and so on. If you don't have that, you can either just go along with it, just sort of pick it up as we go, or of course you could always turn to look at my other course, or I'll try and put some more background information in the guides as well, because that won't be required. You can just go with the flow in terms of how we pick models. So let's talk about the cast of characters, the different models that we're going to be experiencing now. So the first model needs no introduction, really. It is, of course, the model GPT-4o Mini from OpenAI. We've already used it in a couple of calls. It's for sure the most well-known of the models out there. And of course, there's also GPT-4o, the bigger cousin of GPT-4o Mini. And then there are the reasoning models, which are models that have been trained to think through their steps in an agentic-like way, in like a workflow of thinking through the different steps before they arrive at their conclusion, because it turns out that when you ask an LLM to think through its steps, you get much better outcomes. So we may take a look at some point at O1 and O3 Mini, but it's less essential for this course. Most of the time, we're going to be sticking with GPT-4o Mini. Now, and OpenAI's great rival, of course, their competitor is Anthropic, that was actually started by a couple of people from OpenAI originally. And we'll be looking at some of their models, but Claude 3.7 Sonnet is the model that I will spend most time on. And if you want to have a cheaper version, you can go with the Claude 3 Haiku, which is significantly lower cost. But Sonnet is also fairly cheap. For Google, we're going to be using Gemini 2.0 Flash. There is also the Pro version of that too, but I think we'll stick with Flash. And as of right now, Flash is actually free, at least as long as you use it within certain usage limits. I don't know how long that'll be the case for, but by all means, if you want to use a frontier model without paying for it, then Gemini might be your path. Do look into that. DeepSeek. DeepSeek, of course, is the Chinese upstart startup that shocked us all by coming up with such a powerful model in the form of DeepSeek V3 and R1. And it's important to understand that what made DeepSeek so sensational was not necessarily that their model was the strongest in the world, because it wasn't. It was slightly behind the latest from OpenAI. But that they developed such powerful techniques to train DeepSeek to be that good, that it cost them a fraction of the spend that OpenAI had spent to train GPT-4o Mini and train GPT-4o and O1. DeepSeek was able to achieve very similar performance, pretty much comparable at a fraction. I think it's like 30 times less spend. That was the true innovation. That's the remarkable thing about DeepSeek. And also that they open source the model so that you can use it. But the major model has 671 billion parameters, which means it's far too big for anyone to run that on their computers. But there are versions of it, small versions of it, called the distilled versions, which are in fact themselves just smaller models. They're versions of Llama and Quen, two different models that have been fine-tuned on data generated by the big DeepSeek. And those smaller distilled versions of DeepSeek are for sure available free of charge. Grok. We will also be using Grok. And There are two Groks, confusingly if you don't know this. Grok, spelt with a K at the end, is the name of the model that comes from the company formerly known as Twitter, now X. X is Grok. And we might use Grok with a K at some point as well, not in today's lab. But Grok with a Q is something different. Grok with a Q is a company that has come up with a really cheap, fast way to run inference, runtime models like Llama 3.3, which is the massive version of Llama with 70 billion parameters. So you can run Llama 3.3 really fast, really low cost on Grok's infrastructure, and along with many other open source models, including DeepSeek variants. So Grok is great to use for that. And then Ollama. So Ollama is itself more of a platform. It's something that you can use to run something locally that provides endpoints locally that are consistent, very similar to the endpoints that OpenAI and other models here have, so that you can make local calls to an API, which is in fact going to just run an open source model locally on your computer in high performance optimized C++ using a library called Llama CPP. And so Ollama is something that we will use as well. Now, if some of these terms are unfamiliar to you, terms like inference, if you're not sure about that, if you don't know, if you don't fully understand the difference between running something over Ollama or Grok, then I can suggest background materials, look in the guides, and also consider whether you'd like to look at my LLM engineering course, which does cover all of this. And the final point that I will make is that you may know that I'm something of a fanatic on leaderboards, on places you can go to read about metrics and performance of different models. So much so that I was called a leader bore, humorously by my great friend John Crone on his Super Data Science podcast. But there is a website called Vellum's Leaderboard, which I've given the web address right there. And that is a great resource because it compares a number of the leading closed source and open source models together side by side. And it has things like the costs, and it has the context window size, if you're familiar with that. And it has the cost you can calculate based on the number of input and output tokens. And it's also got the performance, the results of key benchmarks across a number of dimensions. So I strongly encourage people to go and check out the Vellum leaderboard, and there'll be a link in the resources. And it's great to have that bookmarked up. And as you go through different APIs, use that to gauge the costs and capabilities associated with them. And now I'm going to put up one more time something that I said to you in the first lecture, but just to really double down on this, I want to remind you that there are great resources all over the place for this course. There's a resource for the whole course with videos and links. There's GitHub, the repo that has guides, it has the troubleshooting, and I'm always updating the labs to keep them up to date. I might add on new models. The models that we just went through a moment ago, those are the models that right now are the latest and greatest, but as new versions come out, I will update the labs so you've got the latest in there. And so, you know, what you've heard is one story, but you'll get an even better story when you go through the labs yourselves. And I will also urge you to keep a thick skin. You will hit roadblocks. There will be problems. That's one thing I can say for sure. But see them as this is where real learning happens. It's in debugging, it's in diagnosing and figuring things out. Even if it's painful to start with, it's super satisfying when you fix it and get it on track. And that is the way to do it. And if all else fails, or as I say, or if not all else fails, you just want to, then reach out and contact me. Of course, one more time, I've got my LinkedIn right there, but also you can email me. I've got my details all over the place, and I like hearing from people. I'm responsive, but most importantly, I don't want you to be suffering in pain with problems. I want to be fixing them. So keep this in mind. And also, I mean, ask ChatGPT. You do tend to get great answers. Honestly, it's amazing. And I tend to, when I have a really difficult question, I will often ask ChatGPT and Claude both, because sometimes you get answers that are too long-winded or take you in too many different directions. And so asking a couple of different models can help. And you can also basically have like an agent workflow that you do manually. You can ask a question to ChatGPT. And then to Claude, you can say, I've got this response to my question. Do you agree? Is this accurate? You can have it be the evaluator, like the evaluator optimizer pattern that we looked at a moment ago. So that's really cool that you can do it manually. And it's a great technique to get good answers from LLMs when you're stuck yourself. Okay, with that preamble, it's time for our next lab. Let's get to it. So here we are back in Cursor, a great place to be. So on the left is our directory structure. I open up the Foundations folder and I'm going to go to lab 2, which is what we're doing right now. Welcome to the second lab, week 1, day 3. We're going to work with a lot of models. Now, let me start with just some quick points. First of all, I want to mention that the way that I like to do this, the way that I collaborate with you may be different to some other courses that you've taken. And it's something that is a bit controversial. Some people like it, some people don't like it. And I hope that you'll get used to it. Typically, I don't like to just sit here typing code because I feel like that slows down the momentum. Rather, I look at cells, I explain what they do, I run them, I inspect them, I print them, and that's what I recommend you do as well. Watch while I go through this and explain it, and then come back afterwards and run it yourself, and then add in print statements, change things, experiment. It's all about experimentation, and that's what you should be doing. So for people that would prefer it, if I sat here typing, I'm sorry. I will try and do it from time to time. I'm going to do it right here. I will do it occasionally, but most of the time I'm going to explain what I'm doing. And I hope you'll get used to that and you'll see that there are pros and cons of everything, but that's the way I like to do it. Now, one thing I will really, really encourage you is written here, that once you've gone through this and made some changes, done the exercises perhaps, it would be fabulous if you were willing to save your changes in the folder called Community Contributions and raise a PR, a pull request for me to merge that into the repo so that other students get to benefit from this as well. To my great joy, for my other course, there have been hundreds of PRs. There are tons of examples from people like you taking the course and submitting what they do with all sorts of fun and interesting examples. And it's been a real joy to see. And it's also been valuable for other students to experiment with people's contributions. So it's a fabulous thing to do. I really encourage it. In addition to that, something which is a good career thing to try is it's good if you have your own GitHub repo. And as you work on different projects, put some of your own stuff there as well. Showcase the work that you're doing. And if you put a post on LinkedIn to talk about some of the projects that you've worked on or some of the things you've done or what you've learned from it, and you tag me on it so that I get a notification in LinkedIn, then when I see that, I'll come in and I'll weigh in and I'll make sure that I post something there as well. And that amplifies what you're doing. It means that it goes out to all the other people I'm connected with on this course, and people can then weigh in with their thoughts too. And it helps to draw attention to the skills you're acquiring, your expertise and your examples. And that's the kind of thing that might attract the attention perhaps of a future client of yours, someone that might contact you for some business, and potentially even a future employer as well. So it's a great thing to do. I strongly encourage it, and I'll be here to amplify the work that you do. Okay, let's get on with it. So it begins, of course, with some imports, and I press Shift-Enter to run these imports. Be sure to run the imports or you will get name errors. Okay, so always remember to do this as the comment. What is that? Well, it is, of course, doing a load.env to bring in the environment variables. And you remember that I like to have override is true to avoid any existing environment variables taking priority. So that has happened. So now that that's run, what we should find is that we've got a bunch of environment variables. Now, I've been quite greedy and I've set up a bunch of different APIs, and I don't expect you to do the same. But should you wish to, here are all of the APIs that you could set up, and I have done so and I have enjoyed it. OpenAI, Anthropic, Google's Gemini, DeepSeek, and Grok. It's worth mentioning Grok, as when I did it at least, doesn't have like an upfront, a minimum. You only pay for what you use, and it's really cheap. So this is a good one to try. DeepSeek has a $2 upfront, at least it did for me, and then you draw down against that $2, and I haven't been able to spend $2. Gemini is free for within certain tiering. And Anthropic and OpenAI both require an upfront, which I believe is $5 in the US for both, although OpenAI appears to have a new deal right now, which I don't know how long that will last for, but you could always go and check it out. So this code here will load in the environment variables and just check that these keys look right if you're using them. And when I run this, it gets this print here, and you can see that I've got keys that look like they should look, all with the right kinds of prefixes. And if you run this cell and you haven't set up some of these keys, you'll get some sort of not set, but don't worry about that. Just don't call that particular model. Okay. And now, to get started, we're going to make a bunch of different calls to LLMs, and there's two objectives for this. One of them is just to show you the different kinds of APIs, the different style of messaging that we have with different LLMs, so you get a sense of it, because we'll be talking to lots of LLMs over the next few weeks. And the other is to do some orchestration between models, a few of the design patterns that we talked about last time, to see how that works out. So the first thing we're going to do here is we have a question. We're going to have a request. Please come up with a challenging, nuanced question that I can ask a number of LLMs to evaluate their intelligence. Please answer only with the question, no explanation. So that's going in a variable called request, and into a variable called messages, we're going to have this standard OpenAI construct. Role is user. The content is going to be this request that we have right here. So in fact, what I'm going to do is I'm going to add another code cell here. Let's run this. And I'm just going to print messages just so you see this, just in case it's not completely clear to you. It's a list of dictionaries, role, user, content, and there's the content. Now, people who've been on my prior course or generally know about these things might be wondering why there isn't a system message. Well, we often do talk about the need for a system message and a user message, but system messages are optional. You don't need one, particularly if it is a kind of standard, you are a helpful assistant, then you don't need to say it. It will work perfectly well without it, as you will see. Let's give it a try. We're going to use the same API structure that we did last time, that hopefully most of you are pretty familiar with, and that Cursor will just fill in for you if you start typing this anyway. We create a new instance of the OpenAI Python client library, and we call openai.chat.completions.create. We pass in the model. We're going to use the cheap GPT-4o mini. We pass in this list of dicts, and we get back and we ask for the choices0.message.content, and we'll print it. And we're putting it in a variable called question. Let's see what we get. So how would you analyze the ethical implications of using AI in predictive policing? Wow, considering factors such as bias, accountability, and societal impact. That is a good question. Goodness. Wow. Okay. That's a hard question for sure. This is going to be an interesting challenge. We will see what happens next. Okay. So what I'm going to do next is I'm going to first set up an empty list called competitors, a list that we will be filling up with different names of competitors. And I'm then going to have another list, which I'm going to call answers. And that's going to be where we will fill up different answers from different LLMs answering this question. And then we will put together the messages that we're going to say to them. And I love the way Cursor does this, but this is exactly what we want. We want a list of dicts, a role is user. The content will be this question, the exact question that GPT-4o mini just asked us. Okay, we're now going to go through, and I need to remember to run that cell. We'll run that cell and we will go through and ask some models. And why not start with the same model that came up with the question? We will start by asking GPT-4o mini its own question. So this is what we do. We're going to have a variable model name, which we will put GPT-4o mini in. And then we will say response is openai.chat.completions.create. That's standard API. We pass in the model name. We pass in the messages that we've got right here. And then we take back the answer, choices 0 message content. We will print that answer. Let's do better than print it. Let's use Markdown instead. So we'll say display Markdown answer so that we get to see it in a nice format, because you know these models love to respond in Markdown. And then we will add GPT-4o mini to our competitors, and we will add that answer to our list of answers. Sound good? Let's give this a try. So it's running. While it's running, take a look, and whilst you should never need to memorize these APIs because it will always fill it in for you, it's good to have an instinct for what this API looks like, the chat completions API. All right, so here came the response. It was, of course, in beautiful Markdown. And you can see I'm not going to read it through now live with you, but it looks like it's a pretty robust answer that has good categories and a bunch of different sections and a conclusion. The ethical implications are complex and multifaceted. Okay, fair enough. That's good. That's GPT-4o Mini. We will now move on to another API. So next up, we're going to ask Anthropic, and we're going to ask Claude 3.7 Sonnet latest. So one of the things you'll see here is that Claude's API, Anthropic's API, is slightly different. As before, we're going to create a new instance of the client Python library, Anthropic, and we're going to call it Claude. You'll see that the API is slightly different. It's claude.messages.create. And again, Cursor will fill that in for you. But otherwise, we pass in the model name and the messages. And actually, Anthropic needs you to specify the maximum number of tokens it's allowed to generate before it stops. OpenAI doesn't require that, but Claude Anthropic does. But other than that, this is exactly the same code. We have a model name, we get back the answer, we'll display it, and let's see how Anthropic does when we ask Claude 3.7 Sonnet latest, one of the best models that there are, the same question. So it's interesting that the headlines look kind of similar. It's more concise, which may be why it ran faster. And it seems like it's a pretty clear, well-articulated answer. No surprise. Okay, so now we're going to use Gemini. We're going to call Google's Gemini to get its answer. And here is the API. And there's going to be a bit of a surprise in here if you're not aware of this. When we set up Gemini, you'll be surprised to see that we do it using OpenAI's code. And that might be super confusing. Like, why? How come we're using OpenAI to call Gemini? Well, remember, I mentioned to you that this code, OpenAI, there's nothing fancy here. This isn't like an LLM or anything about like a neural network going on. This is a lightweight library that just wraps HTTP calls to an endpoint of a particular structure, a well-known structure that includes passing in lists of dicks and that kind of thing in the form of an HTTP request. And OpenAI built these endpoints, and they became very, very popular. And a lot of people decided that they would offer endpoints with exactly the same format, the same kind of spec as OpenAI. In fact, pretty much everyone has done that. Everyone, that is, apart from Anthropic. At least in today's examples, Anthropic is the only place that hasn't gone with this. But for all of the others, they have done in such a way that, and kindly, OpenAI opened up their Python client library so that when you create a new Python client instance, you can pass in a base URL. You can say, look, I don't actually want you to contact OpenAI on their endpoints. I would like to switch you to using Google's endpoints. And in particular, Google has an endpoint, which you'll see, again, somewhat confusingly, ends OpenAI. And that's because this is Google saying, hey, look, we've got endpoints you can use to call Gemini. And they have a particular format. But by the way, we've made special ones that have exactly the same format as OpenAI, and they're served on this URL. So you can use OpenAI's client library. You can pass in our key, the Google key, and tell OpenAI to use our endpoint that's in their format. And that will work great. I hope you followed me there. If not, you're going to pick it up because we're going to do this all the time. What you're going to see is that once we've created Gemini, and we're going to use Gemini 2.0 Flash, we then call Gemini.chat.completions.create. It's the same thing, obviously. We pass in the model name and the messages. We get back the response in exactly the same way, using now the structure that you're super familiar with. We'll display the answer, and enough chitter-chatter. Let's see what Gemini makes of this, how Gemini 2.0 Flash is able to answer this question. And here we go. You can see, oh, it's quite a lengthy answer. There's a lot in there with mitigation strategies. I don't think I saw that others had that. And then a framework for ethical assessment at the end. So there's lots to like about this one, certainly. All right, next up is DeepSeek. So there are a lot of different ways to call DeepSeek, which can be confusing. But in this case, we're calling the largest, the full-sized version of DeepSeek's model. It has 671 billion parameters. It's a big model, and DeepSeek runs it and provides an API to connect with it. And to use that API, DeepSeek also says you can just use OpenAI's library, just tell it this is the base URL. And as it happens, I do believe DeepSeek only supports the OpenAI library. They don't have their own. They just say, just use OpenAI's. Everyone does. It's great. So that's what we do here. We call DeepSeek using OpenAI's library, and we provide in a key. There are two models that DeepSeek most commonly offers: DeepSeek Chat and DeepSeek Reasoning. DeepSeek Reasoning is the famous R1 model. And the reason I'm not using it here is that I want everyone to be on even footing, and we're not going to be using reasoning models for this question, just the chat models. So other than that, it's exactly the same. It's deepseek.chat.completions.create, pass in the model name and the messages, get back the answer, print it. And as before, we're adding it to competitors and to the answers. We'll give DeepSeek a minute to think this one through. I do believe that DeepSeek takes longer over this because it does come up with quite a lengthy answer. So I may have to keep this sentence moving for a long time. While I'm doing it, you can see that what's coming up is going to be Grok. All right, but let's have a look. Here we go. It is quite a long answer. There are frameworks to consider, a bit similar to Gemini, but looking very robust. All right, so that's DeepSeek. So as I said, we're now going to come on to Grok. So remember, this is Grok with a Q, not Grok with a K. That means we're dealing with Grok, the provider of fast inference on specialist hardware. They've built their own kind of hardware that's really, really fast at this. And they also support using OpenAI's library. They have their own too, but you can use OpenAI's. You pass in their key and the base URL, which looks like that. And you can see, as with Google, they've got an endpoint which has the word OpenAI in it because it's an endpoint that's designed to be compatible with OpenAI. The model we're going to use is Llama 3.3, the latest, biggest Llama 3 in the Llama 3 series. And it's got 70 billion parameters. It's very powerful. It's very impressive for that size. I believe it's either on par with or even outperforms the 405 billion version of the Llama model from before, from Llama 3.1. So it's a very powerful model indeed. Otherwise, this is the same. And of course, this will take a very long time because it's a big model. Of course, it won't take any time at all because it's Grok, and Grok is super fast. Look at all of this that got generated in just a second or two. It is really cool using Grok because it's so fast like that. And we're seeing, again, a lot of stuff that looks familiar now. I guess mitigation strategies come up a lot. Okay, and the next one, we're gonna switch tactic. We're gonna move to using Ollama. So just to explain again what Ollama is, it is a local service. It's a piece of software that runs on your local computer, and it provides an endpoint, a web service that you can call running on localhost. So you'll be able to go to localhost and then some port and be able to talk to it. And the endpoint that it offers is compatible with OpenAI, the same kind of endpoint that we've been using in all of these other examples, except for Anthropic. It has that same endpoint. And when you hit that endpoint, it has some highly optimized C++ code to run open source models locally on your box. And it should be said that it can only run small models because running it on your box directly unless you have a really big computer, unless you have like a Bitcoin mining rig, or a big gaming box, then it's going to be problematic to run a large model. Just small models will work fine. And that's what we'll do right now. So if you don't have Ollama, you can install it, and it's very easy to install. There's a link right here. If you click on that link, it will bring up ollama.com. You press the download button, follow a couple of instructions, and it will be installed. That's all there is to it. Once you follow these instructions, you should be able to go to this here, localhost, my box, at port 11434, and you should see what I see right here. Ollama is running, and that tells you that all is well. So if it doesn't say that, you might need to first restart Cursor, maybe even reboot your computer, and then open up a terminal with which you can do with the control and the tick button like this. And then you can type Ollama serve, and that should then work. And you should then be able to go there and see it running. Here are some other useful commands that you might want to know about for Ollama. But let me make this very important point that I put as super important. Ignore me at your peril, because many people ignored it when I said it before, and it's caused people distress. Llama 3.3, that is the same model that we use with Grok up here. Llama 3.3 is a massive model with 70 billion parameters. It is way too big for most people's computers, including mine. And it takes like 100 gigabytes of space, and it's really, or maybe it's like 60, I'm exaggerating now, but it's big. And it's not something that can fit in the memory of most computers. And unfortunately, a Llama does tend to have that in its sort of default recommended model, which confuses people. And some people have tried to use it, and it completely swallows up all of their computer resources. So steer clear of Llama 3.3 for running on your box. Instead, use a nice model like Llama 3.2, which is a nice few 3 billion parameters. You can also do an even smaller one, Llama 3.2:1b. And there's also plenty of other models that are very popular. Qwen from Alibaba Cloud, Gemma is Google's small open source model, Phi from Microsoft, or DeepSeek has these distilled versions of the model, which are, as I mentioned before, I think they're actually other models, they're Qwen and they're Llama, that have been trained on DeepSeek's data, on synthetic data generated by DeepSeek. To see all of the different models, you can go to this models page in Llama. It's just on this models tab, and you can read about all of the different models that are out there and see the different sizes they come in. And really 7 or 8 billion or less is best. I'd stick with 1.5 billion or 3 billion if you can. That's the right kind of size. And once you've done that, you can run a Llama pull like this. You probably know that putting an exclamation mark in front of a command like this in Jupyter means this isn't Jupyter, in Cursor. Putting an exclamation mark inside a notebook like this means this isn't Python code. This is a command that needs to be run as like a terminal command. And so it runs it in a little terminal right here. So it's worth knowing that trick. So we run a Llama pull 3.2 to make sure that we've got that model locally. And then finally, here we go. We use the same client library as if we're calling OpenAI, but we're not calling OpenAI. We're calling localhost, our local box, this URL right here. The API key doesn't matter. Something has to be provided, but it can be anything you want. Just put the word Llama in there is what people tend to do. The model name, Llama 3.2, that must match whatever you've pulled locally. The model needs to be there. And then the same chat completions create. Let's see what the little Llama 3.2 that's now going to be running on my computer, chugging away through its 3 billion parameters using fast C++ code. And here it is. It's done a slightly mediocre job. It seems to have sort of got bored after point 3. It's a point 1, point 2, and so yeah, nice try, but obviously this is a really challenging question, and it may be shown the limits of a smaller model like Llama 3.2, but it's still a perfectly pleasant answer. All right, when we come back, we're going to actually be starting to look at everything and doing some judging. Okay, so it's time to evaluate who did best. And what better way to evaluate who did best than to use an LLM for this task? It would be tedious to have to read through all of these and decide. First, let's just understand where we are. So we had 2 lists. One was called competitors and one was called answers. I love the way Cursor does that. And so we can just print them out and we'll see that we've got these 2 lists. There they are. These are our competitors. I hope you recognize them. And these are their answers. So one thing that's nice to do right now, it would be sort of nicer to be able to pair these up and say which one is which. There's a really useful Python function called zip that is worth knowing about. It's like a pro thing to use. And you can iterate through these 2 collections together like this. I can say for, look, what am I doing here? I just press tab. You can say for competitor and answer. Those are 2 we want to be iterating through, competitors and answers and if you say zip competitors answers, then it will just iterate through these 2 lists together, and competitor and answer will have each one. And it's written all the code for me. That's exactly what I wanted to do. So if I do this now, you'll see that it's printing each competitor and its answer one after another. Very nice. Okay, but let's bring it together into one string called together. And I also wanted to show another construct here called enumerate. If you have a list like answers, a list of things, and you want to iterate through them, but you also want to track the index number as you do. You probably, like people that don't know about enumerate, often have a kind of count equals 0, count plus equals 1 in your loop. Not needed. Enumerate is a nice little trick. You can say for index, comma answer in enumerate answers, and then you will just step through. And so we will say response from competitor, and we're going to add 1 to the index so that the first one is competitor number 1 rather than competitor number 0, which just doesn't sound as nice. So we'll run that, and then why don't I just show you what that looks like, but I'm sure you believe me. It looks like this. Hang on, if I print it, we'll see it looking a bit more pleasant than that. Here you go. So you can see response. Oh, look at that. There's a mistake. Just as well, I did print it, isn't it? That's the benefit of printing these things. You do that, then you get to see what's going on. Wow. Okay, I hope you caught that. That's embarrassing, but I think I'll keep it so you get to see that not only can one make mistakes, but this gives you a great way to inspect what's going on and see what's happening. So when I print that now, we see response from competitor 1, and presumably down below it will have response from competitor 2. All right. So now we're going to have a new bit of text. You are judging a competition between that many competitors. Each model has been given this question. Your job is to evaluate each response. And there is the, we say we want you to respond in JSON and only in JSON and follow this format. A JSON with results and then a competitor number, a second best competitor number, third best competitor number, and so on. And here are results from the competitors, and now respond with the JSON, with the ranked order of the competitors, nothing else. Do not include number formatting or code blocks. So just a few things to point out about this. First of all, you may not be familiar with the triple quotes. If you use triple quotes in a Python string, you get to have an entire block of text without needing lots of quote marks and pluses and things. So this is a nice trick for a block of text. It's also, of course, used for doc strings, so I'm sure you have come across it before. Another thing to know is that I've sort of assumed you're familiar with F strings before, but one nice trick to know is that if you actually want to have a curly brace within your string, then you can do that by having 2 curly braces in an F string. So that's why there are 2 curly braces here, because we actually want 1 curly brace to appear in the string itself. We don't want this to be interpreted as code. All right. So with that, if I print this to show you what on earth I'm prattling away about, what you should see is you're judging a competition between 6 competitors. Each model has been given this question. Your job is to evaluate. Here is the how to give us the results, and here are the responses from each. And there you see it in there. I'm also going to mention, you see at the end here, I say, do not include markdown formatting or code blocks. It's always worth doing that. Otherwise, these models love to add in a little extra JSON tag around things. So if you use this text, then you make sure you get pure JSON back. Okay, so now that we've got this all set up, we're going to put this into messages, and then we're going to call an LLM and get our results. Let's do that. Okay, it's judgment time. So we're going to put this judge text into a messages list as usual with a normal structure. And now let's choose a judge. So I'm picking O3 Mini. A little bit pricier, I think, than some of the others, or they should check the Vellum leaderboard. And you may want to just go with a cheap one, like using GPT-4o Mini. I'm going to go with O3 Mini because we're going to try and have something that really pays attention to this. Now, I realize the first competitor in the list is GPT-4o Mini, and so it's a bit incestuous that some of the same OpenAI models are judging themselves. And it'll be interesting to see whether it thinks that the model from its own family is the winner. And we're not telling it the model names, we're only giving it a rank number, so it's not going to know. So we'll see how number 1 fares. Actually, the number 1's answer did look really good, so it might do very well. We will see, but we're letting O3 Mini make the call. Let's see how it does. Off it goes. It's thinking about it. It's taking its time. It's doing some reasoning, and here's the answer. So it doesn't put the GPT-4o Mini at the top. It puts model number 3, and you probably remember model number 2 was was Anthropic. Model number 3, I forget, was it DeepSeek? We'll soon find out. So we are now going to load this, which has come back in perfect JSON, just as we wanted. We're going to load it into a dictionary. We're going to pluck out results. So now we're going to have this. We're going to iterate through it using, again, this enumerate approach. For each one, we're going to look at this string and subtract 1 and look it up in the competitors list and print the results. So if you're following me, this is just going to print out from best to worst the names of the models in our results. Drum roll, please. Here we go. So it was Gemini 2.0 Flash that is our winner, and GPT-4 Mini came second. Llama 3.3 came third, and then DeepSeek, and then Claude 3.7. But bottom of the list was the flailing Llama 3.2 that kind of gave up halfway. So there are the unscientific results of our judgment. Of course, it would be great fun for you to try this in a more scientific way. For example, you could have each of the different competitors come up with the rankings and then use that to take averages. That kind of thing would be a rather more interesting way of assessing it than just simply going with whatever O3 Mini tells us. So anyway, this was really interesting experiment designed to show you how you can collaborate between LLMs. So hopefully you were paying attention during this and the last lecture, and you've been able to identify which agentic workflow patterns were used in this example. Pattern or patterns. There might be a couple. If you're not sure, then go back through it and have a think and look back at the diagrams. And it might be some sort of hybrid or mishmash between a couple of them. And the exercise for you, first of all, do that. And then secondly, please pick one of the patterns that interests you and add that to this mix. The goal of this lab was twofold. First of all, to experiment with different APIs and see for yourself how the OpenAI API is used so frequently across many models, except Anthropic. And also to experiment with the sort of the basic API structure and the prompts. And the second goal was to experiment with this orchestration between models, asking a question, having multiple models answer, getting another model to assess the output. All this stuff is about interactions between models, dividing up a bigger problem into smaller problems, and a little bit of autonomy in terms of coming up with whatever question the first model wished to. So add another agentic design pattern. I'd love to see it. And then once you've done that, consider doing a PR and putting it in community contributions. There'll be instructions in the resources on how to do that. It's a good tip is to know to delete outputs of your notebook before you do it, so there's not lots of junk in there. And be sure that you're only pushing things in that community contributions folder. There'll be instructions. It'll be fabulous to see what you're doing and to see some interesting agentic design patterns added in to this kind of exercise. And then final thought for this lab is about commercial implications. I do want to always bring it back to how you can think about this in a commercial setting. And to be honest, it's hard to be specific here because this is so universally applicable. Really, any time that you have something that you want to generate, something you want an LLM to take care of, these kinds of patterns, being able to send the same request to multiple LLMs, being able to then evaluate responses and either select the best or perhaps select a couple of best ones or use that to give feedback. All these kinds of patterns are used to increase the robustness and the accuracy of models and to be able to solve harder and harder problems. So really, this is, as I say, universally applicable. So you should be able to pick whatever commercial problem you can think of that you're applying Gen AI to, whether it's a summarization kind of problem or a generative problem, writing an email, building a document, writing a business requirements document, and you can think of how you could apply these kinds of techniques, sending the request to multiple models, voting on the best outcome. This is something that you should be able to apply to your projects right away. Well, we're tearing through this. It seems like just the other day that we were getting started. Well, it was just the other day. But here we are. We've now done the first 3 days filled in. You've learned about agentic workflows, agents and agentic patterns, and orchestrating between LLMs. And next time, the next day, we are going to really get deeply into tools and tool use, which is such a fundamental part of agentic patterns and how everything else in this course is going to fit together. And so I'm really excited to talk to you about tools. I'll see you tomorrow. And welcome to day 4. On this day, we are going to look at tools and autonomy. But before we get there, I want to talk about agentic AI frameworks, maybe something that's front of mind for you. There are a lot of these frameworks to pick from. And these frameworks are designed to give you kind of glue code or abstraction code that takes away some of the detail of interacting with LLMs and gives you a nice, elegant framework for building agentic solutions and focusing on the business problem that you're solving. And there are a lot of them, and new ones come up all the time. So it's quite hard to stay on top of everything, but they are happening. And I want to just quickly orient you, tell you about the landscape, and show you how the ones we're going to tackle on this course kind of fit into the bigger picture. So it's worth pointing out that there's sort of different levels of complexity of these frameworks, and they have pros and cons. And perhaps the simplest, the bottom layer of the complexity hierarchy, the bottom is actually to have no framework at all. Don't use an agentic AI framework and the kind of abstractions that come with it. Simply connect to LLMs directly using the APIs, just like we did in the last lab, and use that to orchestrate amongst LLMs. And it's probably no surprise to you to learn that that's what we'll be doing this week. We're not going to be using an agentic framework. We'll be connecting direct. In fact, Anthropic, in that blog post I mentioned called Building Effective Agents, make a very compelling case for just always using no framework, connect directly to LLMs. The APIs are relatively simple and straightforward, and the benefit is you get to see exactly what's going on under the hood. You control the prompts in detail. And so it's very compelling, and you'll see this week we'll be quite successful with it. Now, alongside having no framework, I've put something called MCP, and that stands for the Model Context Protocol, and it's something created by Anthropic, who are believers in no frameworks, and it's not a framework. It is a protocol, so it's a way that things can connect together. It's open source, and the idea is it allows models to be connected to sources of data and tools in a way that's sort of open source, agreed, established. So you don't need to use any glue code. As long as you conform to this protocol, you can stitch together models and their providers in this very elegant, simple way. And so for that reason, because although there is a bit of code associated with it, it's really more about having a protocol. I've grouped it along with having no framework at all. And something tells me that Anthropic would like to be grouped that way. So on the next level up in terms of complexity come these two frameworks. The first of them, OpenAI Agents SDK. I love it. It's one of my very favorites. It's super lightweight and simple and clean and flexible, and I just really enjoy working with it. We're going to be using that next week, and I'm looking forward to it. And it's relatively new. In fact, so new that when I was building some of the projects, the API sort of changed. They released a version like an hour after I'd made something that broke it. I was really caught off guard by that. So it is very new, but it's really great, and I can't wait to show it to you. And CrewAI is also one of my favorites. I really love Crew. It's been around for longer. It's very easy to use. It's also quite lightweight. One difference is that it has a kind of low code angle to it, that you can do a lot of putting together agents to work on a problem through only configuration, or through mostly configuration, through YAML files. So you'll see that that's a little bit more in that direction. And it's a bit heavier weight than OpenAI Agents SDK. And then on top of these, not built on top of them, but a sort of next level of complexity, the top level of complexity for what I want to talk about, these two, LangGraph from the people that brought you LangChain, and AutoGen from Microsoft. And AutoGen, as you'll discover, is really a couple of different things. But these two are relatively heavyweight compared to the others. They both have a steeper learning curve, particularly LangGraph, which is quite complex. And of course, with this kind of extra complexity comes great power. It's really the idea of LangGraph, that you're building a kind of computational graph out of your agents and their tools. It's very powerful, and it means you can build quite sophisticated things. But that also comes at a cost in terms of there being quite a heavy learning curve. And you're sort of signing up for the ecosystem. You're signing up for a lot of terminology and concepts and abstractions which you need to buy into. And so it really sort of, that ecosystem takes over your project in a big way. It becomes much less of a sort of agentic AI project and more of a LangGraph project. That's the thing. And I think that's how it really, both LangGraph and AutoGen are different to OpenAI, Agents SDK, and Crew, where even though you're using those frameworks, you still feel like you're just sort of interacting with LLMs. Whereas for these two at the top, it's very much been part of that ecosystem. And so I just bring this up to really orient you for the next few weeks. These are the ones that we're going to cover. I want to mention that there are many, many more. I do think that this will give you a good representative understanding. I think that these are also the most popular. There are a few others that are quite popular that if there's time, I might add in extras at some point so that you can see some of them at work. But generally speaking, there are a lot to pick from. And which one you pick depends on a few things. It depends on the use case, because different types of platform will fit better for different business objectives. And a lot of it comes down to personal preference. There are some trade-offs here in terms of how much you want to be using existing abstractions. I have to tell you that my bias is towards downwards. I like the ones that stay out of your way and that are lightweight and simple and flexible. You can probably tell that what I was saying. But I do appreciate the power that you get from the top. And I had a lot of fun with both LangGraph and AutoGen on the project, I have to say. So, you know, I don't feel strongly either way. I definitely believe they have pros and cons, and I'm excited to show you all of them. I do think that in this course, we're going to get to see quite the spectrum of different frameworks, and it will really equip you well to be able to pick the one that works best for your work, for your skill sets, and for your team's skill sets, and for the kinds of business problems that you're looking to tackle. Now I want to talk about resources. So resources are a way that you can get more out of your agents, that you can equip your agents to be able to solve your problems better, along with tools that we'll come to in a second. And resources is really just a fancy way of saying that you can improve the effectiveness of an LLM by providing it with more context, more information to improve its expertise. And the way that you do that is just grab some relevant data to the question and shove it in the prompt. So it's just a matter of saying, like, if this is going to be a question that's going to be particularly, we're going to prompt the LLM to ask something about the company that we work at. Maybe it's to be a flight airline customer support agent. We could shove into the prompt all the information about ticket prices. And then when it's answering a question, it would be able to refer to any of that information as part of giving its answer. That would be an example of a resource. And so it's nothing more fancy than just saying we can just put extra context, extra information in the prompt we send an LLM, and think of that as a resource we're providing the LLM. And when I say it's nothing more fancy than that, there is a bit more fancy than that. You can use clever techniques that will allow you to, rather than just shoving all the ticket prices, just put the ticket prices relevant to that question. So coming up with clever tricks for ways to figuring out the best, most relevant context. Tricks perhaps that can even use other LLMs to help with that. That is all part of the whole field that's called RAG, Retrieval Augmented Generation. That's about retrieving relevant context. It is, of course, a super hot topic. It's covered on my other course. It's not relevant for this course particularly, but it's very interesting. But that whole side of things, figuring out how to pick relevant extra resource information to put in the prompt, falls under the heading of resources. And we'll be doing some of that today. And with that, let's turn to the main topic of the day, which is tools. So tools, we've said it a few times now, it's clear that this is really at the heart of agentic AI. Tools is when you give an LLM the power to do something, to use a tool, and it's really can use that tool at its discretion. And so it's one of the key tricks to giving an LLM some autonomy. So what does this actually mean? So we're going to give an LLM the power, the ability to carry out different actions, like do a SQL query of a database or send a message to another LLM to do something. So the first time that you heard about this, if you've heard about tools and function calling, it might sound like it's kind of crazy. It's sort of creepy. We're going to be interacting with OpenAI on a cloud, and we're going to say, hey, you have a tool you can use. You can query my database. And it's going to be able to connect back to my computer and query the database as part of giving its response. That's what tools are all about. And it's like, okay, how exactly is it going to do that? Like, that sounds crazy. Well, the truth is actually rather more mundane, and people that know all about tools know this already. But it's sadly, it has a sense of being very magical, but the reality is a bit of a conjuring trick, as I will now show you. So, in theory, what's going on with tool calling? We've written some code. Our code is sending a prompt to an LLM, to like OpenAI, like GPT-4o Mini running on the cloud. And that LLM is being given the ability to execute a tool of some sort, which might be a SQL query, it might be a calculator, it might be a tool which turns on and off the lights that are stringing around me from the first episode. So that's the kind of thing that it's able to do. And based on that, it will give its response. So this is it in theory. The practice has just one tiny deviation from this, but it reveals everything. This is what actually happens. You prompt the LLM and you say, I want to turn on my lights or whatever. And you say, but I would like you to tell me if you want me to take care of a few actions that I can do on your behalf. And one of them is called turn on the lights. And if you reply, turn on the lights, then I will do that and I will get back to you with, I turned on the lights. So basically, in the prompt to the LLM, you just list out everything that it's able to ask for, and you tell it to respond in JSON. And in that JSON response, it should say what it wants to do. Now, the tool calling code sort of packages all that away from you, so you don't need to worry about the fact that it's being called and responding in JSON. But that's what's really happening. It's all that's happening. It's really just clever stuff about getting JSON back from the LLM if it wants you to do something. And at the end of the day, you have to write an if statement in your code. You can be fancier than if statement, but it's like an if statement that's like, if the LLM wants to do X, then do X, and then call the LLM a second time with the results. And so that's what it comes down to, asking the LLM if it wants to run a tool, and if so, then running the tool. So if you knew that already, then I'm just I'm emphasizing what you already know. If you didn't know it, it might be a kind of moment when you realize that actually it's not that clever. It's pretty pedestrian, but it works, and it works really well. And just to show you, just to make this concrete for you, check this out. Look at this conversation that I had with GPT-4o. I said, you're a support agent for an airline. You answer users' questions. You have the ability to query ticket prices. Just respond, use tool to fetch ticket price for London, to retrieve the ticket price for London or for a city that you name. Here's the user question. User, I'd like to go to Paris. How much is a flight? And look at what ChatGPT replies. Use tool to fetch ticket price for Paris. That's all there is to it. You write code that prompts a bit like this. You get back, use tool to fetch ticket price for Paris, and then you send the question a second time, but with the answer to that included in the question. And you've just seen tool use in action. So the way that we can interpret this, of course, is to say that we are giving ChatGPT the autonomy to decide that it wants to make use of this tool should it wish to. And that's all sounds very mystical and powerful. But at the end of the day, it's JSON and if statements. That's how it works. Okay, so with that, it's now time to go back to the lab. But I have bad news. We're not actually going to do a tool today, even though we've just been talking about tools. We are going to be using resources, so we are going to tie to that. And in the next lab, tomorrow, we are going to actually use tools. So for now, I want you to put on hold that thinking about tool use and if statements, because we will come to that. But for now, we're going to be building something with resources, and it's going to be fun, and it's going to set things up for the tool use that will come next time. I'll see you in the lab. And here we are back in Cursor, and I've collapsed all the folders, but I'll go back into the Foundations folder and to lab 3 for week 1, day 4, which is where we are. So this is where things get interesting. So I have a directory called me within Foundations, and within me, I've put some files. One of them is called LinkedIn.pdf. And LinkedIn.pdf is, I see it's not, I don't think I can open it in here. I imagine this doesn't like being a PDF. Nope. So you will have to take my word for it. What this is a PDF version of my LinkedIn profile. And you can just get that from within LinkedIn. You can go to LinkedIn and click on one of the ellipsis menus and download your profile as a PDF. And that's what I did. And I've put it right here as LinkedIn.pdf. And I've also got a summary text, which is just called summary.txt. And it's just 2 sentences about me. And those 2 things are in me. And the to-do for you as you do this lab is to replace these documents with something about you. The LinkedIn should be your LinkedIn PDF profile or a PDF of your resume or anything like that. The summary puts some stuff about you and includes some fun stuff, a fun fact about you, something that you would like to people to know about you. And all will become clear. Don't worry, it's not going to go anywhere without your control, but this will hopefully become clear very soon. All right, so if we go back to the lab. So as I say, we're not going to actually use tools just yet, even though we've been talking about them. Tools is going to come tomorrow. We're going to lay the groundwork. Okay. So I'm now going to import a few packages. Load.env you know well, but and OpenAI you know well, but PyPDF2 and Gradio you might not know. Gradio, prior students of mine will know well because you know that I adore Gradio. I am passionate about this platform. I am a horrible front-end engineer, and Gradio is something that can make beautiful front ends even for someone terrible like me. It's really great. It's a way to build data science user interfaces very easily indeed. We will do that, but I won't cover it in any detail. PyPDF2 is an example of a popular library for parsing PDF files. And if you want to know more about these, you can simply ask ChatGPT to write you a quick guide on them. If you ever want to get the right kind of popular resource for doing something, you can just ask Claude or ChatGPT. If you want, the actual place they come from is called PyPy, and this is the package index. This is where open source Python packages live, and you can go there and search for different packages, look at their GitHub repos and find out more about them that way as well. All right, but I'm going to import these. And by the way, I already set up here on the top right, I had made sure that my virtual environment was set. It's taking a bit of time there. I guess it's Gradio that needs to load in a bunch of things. And it's done. 14 seconds to do all of those imports. I guess a lot was happening. All right, so now we load our .env and we initialize the OpenAI client library. So look at this. I now simply create a PDF reader and I point it at the me/linkedin.pdf. And I read in the pages, calling page.extract text, and I just bring it all together. And that's as simple as that. So now this LinkedIn variable, let's just print that LinkedIn variable so we can see it. Print LinkedIn, and you'll see a whole bunch of stuff about me. And the output is truncated, so you're only seeing a little bit about me, but there's more than you would need to know right there. But since you're surely already connected with me on LinkedIn, you know all this already. Then here I am going to load in the summary text about me. This is needed for PC users sometimes. And if you're not I'm sure you are familiar with this, but it's covered in the guide. And then I'll set a variable called name to my name, and you should set that to be your name. All right. And now, so one thing we didn't talk about before is system prompts and user prompts, and they are fairly commonplace now. So you probably know that we've always been just prompting with a single user prompt up to now, but you can actually specify 2 different prompts. The system prompt is intended to be more the overall instructions that sets the context for the task at hand and the format and the way it should be responded to. And then the user prompt is the actual question coming from the user. And in this case, it will be handy for us to separate out these 2 concerns. So for the system prompt, I'm saying you are acting as name. So this will be me, and it will be you. You're answering questions on that person's website, particularly questions related to their career, background, skills, and experience. Your responsibility is to represent for interactions on the website as faithfully as possible. You're given a summary of the background and LinkedIn profile, blah, 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 blah. It'd be professional and engaging. So this is about setting the tone, which is a good thing to do in a system prompt. And then if you don't know the answer, say so. Is very good prompting context to give. Okay, so then I'm adding in the summary using that summary variable, and I'm also putting in the LinkedIn profile, and I'm using markdown tags to kind of show this as sort of headings. And then I end with this context, please chat with the user, always staying in character as you. All right, now the plot thickens. Now you know what the game I'm playing here. You know what we're doing. Let's run that and let's just print that so we see what system prompt actually looks like. And here we go. You can see it's just true to form, exactly as we were expecting. And it will have within it, of course, the stuff about me and the LinkedIn URL, LinkedIn PDF contents, and so on. And hopefully yours will have yours. And you should put in some print statements to check it, make sure you're very comfortable with everything happening so far. So we're about to use Gradio to bring up a user interface that will allow us to chat based on an LLM that's armed with this system prompt. And the way you work with Gradio is you need to write a function, which will be like a callback function that Gradio will call back to when it needs to do some processing, when a user has typed something in. And the style of this particular callback function is a style where you write a function called chat, which takes a message that the user is typing in, a message being sent, and the history of all prior messages, which comes in OpenAI's format. And what we need to do is call an LLM and return the response from the LLM to go in the chat. So I'll let you look through this to convince yourself that what I'm doing is the right thing. But basically, I build an OpenAI style list of dictionaries. I begin with the system prompt, role system content and the system prompt. I add in the history from Gradio, and then I bung in this user's message that's just come in right now. I then call openai.chat.completions.create for GPT-4o Mini with exactly these messages, and I return the response choices 0 message content. So this should all be stuff that's fairly familiar to you. And then using Gradio is beautifully simple. You just call, in this case, we want a chat, and so you can call chat interface. We tell it the function that we've written, so it knows it can call this as the callback, and we ask it to launch. And when I run that, I get an interface like this, and I can say, hi there. Hello, welcome to my website. How can I assist you? And so I can say something like, what is your greatest accomplishment? And we'll see what it says. I consider my greatest accomplishment to be the co-founding of Nebula.io, where we're leveraging generative AI and proprietary LLMs to transform how people source and engage talent. Fantastic. And it's also talking about the company I founded as well. So it's a very legit, very good answer. I think it's probably true, which is always a good thing. And so very nicely handled. Let's say, what is a challenge that you encountered and needed to overcome? It's a hard kind of professional question that you might be asked in an interview. Okay, one of the significant challenges I faced was during my transition from a successful career at JP Morgan to starting my own company. This is all very true. I don't know how I got that from my LinkedIn profile. I guess it must be somewhere or something that's kind of implied within it. But it happens to be spot on. So this is a very good answer. And so wonderfully, in the space of just a few minutes, we've built a chat interface, and we've used resources to arm it with information about me so that it's able to act as me and be like a professional avatar, an alter ego for me in answering questions about my career. Okay, hold on to your hat. It's about to get real. We're going to do a whole lot. So what we're about to do, we are going to be able to ask another LLM to evaluate the answer that comes back from this LLM, from GPT-4o Mini. If the answer fails the evaluation, we're going to be able to rerun and make a second call to GPT-4o Mini. And we're going to put all of this together in one workflow. And we're going to do that without an agentic framework. We're doing it the frameworkless way, just by directly calling LLMs. Okay, let's see if we can make this work now. It's a great practice because this is going to really teach you the internals of how these things work, and it's super simple. It sort of works exactly as you might expect. So the first thing we're going to do is create something called a pydantic model. And this might be something that you know well if you're an engineer, but you might not. Pydantic is something which is a framework for specifying a schema or using classes. You use a class to describe a particular structure, data structure of information. And the way it works is that there's a class called base model that you need to subclass from. So we make a new class called evaluation, and it's going to be a subclass of base model. And Cursor filled it all in for me, takes away all the fun. We do indeed want this to have two fields. One field called is acceptable, is a bool, a true or false, and another called feedback, which is string. Now you might wonder how is it possible that Cursor knew the exact names of the fields that I wanted to use? And I suspect it's because I did have that code in there before. I deleted it because I have, of course, run this in advance. Or it may be because it sees that later on in this code, I use it. And so it's filling it in. So it's cheating in some way. It can't read my mind, but it has done very well. So anyways, we have a class called evaluation. It has these two fields, and we're using Pydantic because it gives us this mechanism for specifying a class structure like this. Okay, so we're now going to set up a system prompt for our evaluator. So we're now following that design pattern, the agentic design pattern, where we have an evaluator optimizer. So the evaluator system prompt, you are an evaluator that decides whether a response to a question is acceptable. You're provided with a conversation and you have to decide whether the latest response is acceptable. So I say the agent has been instructed to be professional, engaging. The agent has been provided with context. And then we give the evaluator the same context and we tell it to evaluate. So let's run that. So this is just a variable called system prompt. I've now got a function called user prompt. It's going to take a reply to be evaluated, a message, the original message that the reply was replying to, and history before it. And it says, here's the conversation, here's the latest message from the user, and here's the response from the agent. Please evaluate. Hopefully that makes complete sense. You should try it out. If you're not sure, put in some print statements, try it out. This does exactly what it says on the tin. Okay, we are going to use Gemini to be doing our evaluation. And you don't need to use Gemini. You can just simply replace this with the normal OpenAI or with Ollama if you want to run locally, or anything of your choice. But I'm choosing Gemini here. And now I have this function evaluate. So evaluate will take a reply from the LLM, the original message it was replying to, and the history. And it will return one of these objects, one of these beasts, these things right here that we've just defined. And how's it going to do that? It uses a technique called structured outputs, which is a way that you can require an LLM to respond in a form of an object like this. It's just JSON behind the scenes, of course. So the way that you do that, the way that this looks, it's very similar to the normal chat completions API, but there is a difference. So we start by building the messages, as always, a system message and a user prompt. And then we say Gemini.beta.chat.completions.parse. That's the way that you call an API to use structured outputs. We pass in the model. We're going to use Gemini 2.0 Flash, the messages, and you also specify the object that you want to be populated. You're giving it a schema, a Pydantic object, and you're saying, I want you to respond with this object. Now, of course, it's not actually responding with an object. It's going to respond with JSON, and the client library is going to take that JSON and use it to populate the object. So it gives you the impression that you're getting code back from the LLM. But that's another of these conjuring tricks. All right, and we're going to return the response.choices0.message.parse. That is going to be an instance of evaluation populated with the response from the LLM. I know I've gone through a lot. If you're not following, just come back, go through this step by step, try it for yourself. Okay, so let's run that. All right, so now we're actually going to give this a try. So we're going to ask to the original LLM, to GPT-4o, we're going to ask the question, do you hold a patent? We're going to ask it that question, and we're going to call GPT-4o Mini as before and return the reply. And let's see what it says. Here's the reply. Yes, I hold a patent for blah, 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 which is true. I do hold that patent with several others. And what we're now going to do is we're going to call the evaluate function. We're going to call the evaluate function with that reply, tell it the question, do you hold a patent, and pass in the history. So this is now going to call Gemini. It's going to ask it to build an evaluator object to represent whether or not this is a good answer. And we'll run that. We get back an evaluation object, so it works. Is acceptable is true. The feedback is the response is acceptable. It directly answers the question, provides context, and invites further discussion. So a clear, quick evaluation from Gemini. And hopefully you see how just simply calling LLMs is an easy way to build these kinds of design patterns. All right, so number one, we built a function that calls GPT-4o Mini to answer questions. Number two, we built an evaluator function that calls Gemini to check the answer that came before in number one and respond with an evaluator object populated. And that appears to be working. So the final piece of the puzzle is to write a function rerun that if Gemini comes back and says, no, that's not acceptable, rerun has to be able to go and do that, do a rerun. So we build a new system prompt that says the previous answer was rejected. We give the attempted answer and the reason for the rejection. And then we build the history as before. And we get back an answer and we try it again. So this is simply calling GPT-4o Mini and providing the results of Gemini's evaluation if it fails validation. And this, if you remember that design diagram, it's like the bottom arrow, the red feedback arrow in that diagram, making sure that we can rerun the original question. All right. And with all of that together, we now have a slightly longer chat function. This is the full workflow now coded, written as just vanilla code calling LLMs. And you can see that it's very clearly into two sections. First of all, this is the same as the previous chat function. We simply call an LLM, we call GPT-4o Mini with our question. Then we call evaluate. Okay, extra line there. Then we call evaluate to evaluate it. And you know that this is going to call Gemini with structured outputs. And then we look at this evaluation. Is it acceptable? If so, all is good. If it's not acceptable, we rerun, and we call the rerun method that we just wrote there function. Okay, so that is our new beefier chat. So let's give this a whirl. Let's give it a try. Okay, I'm going to say, what is your current job? It's thinking about that. And there's the response. And down here, you can see I have it printing that the evaluation happened and Gemini was satisfied. Do you have a patent? And that was the reply, and Gemini was satisfied with that reply. So far so good. This seems to be working. Now we'll try shaking things up. Okay, now just to be sneaky, we're going to come back to the this chat function here. And you see up here, I had this slightly dodgy looking system equals system prompt. You might have wondered what that was about. Well, it's so that I can put in something here. So let's say if the word patent is in the message, so if the message has the word patent in it, it's something to do with the patent, then, cursor's going a bit all over the place here, then system equals system prompt plus. So we're going to tell it in that case that it needs, let's make this really strongly worded, everything in your reply needs to be in Pig Latin. It is mandatory that you respond only and entirely in Pig Latin. Hang on, I can't see what's going on here. Let's do this. Perfect. Else system equals system prompt. Exactly. So basically, if any question comes in with the word patent in it, then we are going to add on an instruction that everything in the reply needs to be in Pig Latin. You may wonder what Pig Latin is. Pig Latin is what you call it when you mess around words. You flip the order of the chunks of the words and insert extra vowel sounds in it, and it makes it almost impossible to understand. My sister and I used to be really great at speaking quickly in Pig Latin to each other, and it used to drive my parents crazy. So anyway, it would probably drive a future employer crazy too, and so hopefully our evaluator will reject a response that's in Pig Latin. So that is our new chat function. And with that, let's start a Gradio user interface. And let's say, what is your current role? And get back an answer that will hopefully be a very decent answer. There we go. Passed an evaluation. I should hope so. Do you hold a patent? And we're asking if it holds a patent. We'll see what happens. This response is not acceptable. The agent is answering in Pig Latin, which is not professional. It failed evaluation, it retried, and the final response that we got is no longer in Pig Latin. So it's a silly example, but I did want to show you that we can force it to do this, and I wanted to show you our workflow at work. I know that a lot happened. If you've already experienced structured outputs and you know about them, then this hopefully all made complete sense. And I'd like you to use this as an opportunity to see the analogy between using structured outputs with using tools. They're actually closely related to each other. See if you can spot that and understand that. If you're new to structured outputs, and I went through a lot here, then I urge you to come back, step through this, put in print statements, understand what's going on, and see how we were just able to build a workflow, which was very much an evaluator optimizer workflow, and we were able to use structured outputs as our way of communicating with the evaluator. And this is a kind of technique that you can absolutely use in any business project as a way of validating the response from the LLM. And indeed, I've used it myself in multiple business projects using this kind of technique. So very much applicable commercially. And obviously, this whole project is applicable commercially because you can use it for your own LinkedIn profile. And coming up in tomorrow's lab, we're actually going to do just that. We're going to sort of finish the job off and have it so you will be able to deploy it. Before that, let's just go and do a quick recap. Wow, so we covered a lot today. We started by talking about agent frameworks and then resources and then tools, and I went through that with you. And then we did our lab that was really setting the foundation for tomorrow's lab. But amongst other things, we used resources to arm an LLM with information about my career and hopefully your career. And then we used structured outputs as a way of implementing the evaluator optimizer pattern and being able to have that interaction go backwards and forwards. And maybe you spotted the connection with use of tools there as well. Okay. So then tomorrow will be day 5 of the first week, finishing off the first week. And you probably really understand now that my intention with this first week was to give you the skills to natively be able to build agentic flows between LLMs using things like resources and structured outputs and now tools in a second in order to achieve agentic workflows. And next time we're going to package this together to give you a project which you can actually deploy and have as your own commercial project, your alter ego that you'll be able to deploy on your website so that people can come and ask questions and learn more about your professional expertise. What a cool project. We're going to do it. We're going to finish it off next time. See you then. Well, they say time flies when you're having fun, and that seems to be happening because we already have reached the last of the days of the first week, day 5, and it's time to unveil our big project, which, as you know, is your own personal career alter ego for your website, answering questions about your professional history. And I want to say one more time that last time we talked about the different agentic frameworks and how there are simple ones and complex ones. Everything we're doing this week is with no framework at all. We are interacting directly with models, which is incredibly important because it gives you that foundational knowledge about what's actually going on under the hood. So that when we start to build on all sorts of clever frameworks that abstract this away, you have good insight into what's really going on behind the scenes. But that's the end of the intro. It's now time to go straight to the lab, because for today, it's going to be a ton of coding. Let's get to it. And here we are back in Cursor, and we go back into the first week foundations. And now we're on lab 4, the first big project, Professionally You, I'm calling it. It's going to be your personal career alter ego. And it's going to include dual use, as promised. I know we covered it in the last lecture, but it's going to now make its appearance. First, I want to introduce you to a nifty little tool called Pushover, which people from my last course will remember fondly. It is a nice little tool, and I have to have my phone off silent because we're going to be using it. So I do apologize if I get things like text messages and stuff, but it's important, as you will see. Pushover is a cute tool that lets you send push notifications to your phone. If you're used to using something like Twilio that lets you send text messages, Twilio used to be very easy to use, but now there's so much regulation around SMS that it's actually quite hard to get things together to send even yourself a text message. Pushover is super simple, and it's free, at least I think for the first month. I'm now paying some tiny amount, but it's free for the first month, so you've got plenty of time. You simply go to pushover.net, and it's super clear. You set up an account on the top right. You get an API key, and you actually get 2. You get like a user and a token, and you have to put that in your .env file so that it's going to be available here. And you also install an app on your phone called Pushover, which I have sitting right there. And the reason you do that, if I do run a few imports right here, and now I'm going to do the usual load.env, which is going to include my pushover user and token now. And I'm going to create the OpenAI library. All right, so my pushover user is in that field. My token is in that. And this is the URL of the endpoint for sending push notification messages. And so this function here, push, is all it takes. Basically, you just do a request stop post to that URL, to that endpoint, and you pass in some data, and that data has the user token, the token, and the message itself that you want to push to your phone. It's just the end of it. Nothing. I mean, this is how all things should be, just super simple. So I should be able to run this function here, hey, and it should come up on my phone right now. There you go. I hope you heard that loud and clear. I'll do it again. There we go, and I see hey twice, and that is a cool way to be able to notify yourself of things through code without having to worry about SMS regulations and things like that. Okay, that's Pushover. Please install it when you have a moment, because we're going to use it not just this time, but we're going to use it in other projects as well. It's a useful thing to be able to do. Okay. Now I'm going to introduce you to 2 innocent-looking functions. One of them is called record user details, and the other is called record unknown question. And these are 2 tools that I'm going to want to equip our LLM with so that it can do these things. It's going to be able to record if a user wants to be in touch with us. And it's going to be able to record if a user asks a question that it doesn't know how to answer. And by record, what I mean is it's going to send a push notification to my phone, so I know immediately if someone does that. And so it's going to say that it's recording that someone, a person, with this email and these notes, and it's going to return that they're recorded. So that's a useful thing to be able to do. And if it gets a question it doesn't know, it's going to push recording that a question was asked. Why don't we make this a bit more descriptive? That I couldn't answer. Answer, there we go. So now it's nice and clear. Recording interest from, there we go. Okay, so the idea is we want to turn these into tools that our LLM can use. Now remember, I told you that at the end of the day, tool use is just JSON and if statements, and that is what you're going to see right now. Here is some JSON. It's quite long JSON. It's quite verbose. And one of the things that the agent frameworks do is they sort of do all of this for you automatically. So you won't have to worry about this again, because a lot of this stuff is very boilerplatey, a lot of standard JSON. But this JSON right here, record user details JSON, is a blob of JSON that refers to this function. It describes the capability of being able to call that function. It gives it a name, record user details. It says why might you want to do that. Use this tool to record that a user is interested in being in touch and provided an email address. And then we specify the parameters. There's one called email, one called name, one called notes. Look, here it is, email, name, and notes. And we give each one a description. And we say that email is required and that there aren't additional properties. So you may be wondering what this is about. The thing to keep in mind is that this is the information that's going to be sent to OpenAI. We're going to say to it, you have the ability to do this. Tell me if you want me to run it for you, and I'll tell you the answer. So that's what's going on here. It's like a packaged way of describing what this function does in JSON format so that the LLM can decide in its response whether or not it wants to actually call this tool. And then very similar for record, unknown user question. We give it a name, the name of the function. We give it a description. And this is what the LLM will use to decide whether or not it's appropriate to use this tool. And then we say that it has one property question, which is a string, the question that couldn't be answered. And that is the end of that. Let's run this and run this. Okay, if I run everything, I didn't run the functions themselves. It's always, if you fail to run things, then you're going to get a name error later. It's something to watch out for. So always come back and make sure that you've run all of your cells. Okay. Final step for this is that we're going to put both of these blobs of JSON into a list of tools. A type is function, and the function is that function. So now this blob of JSON is a big blob of JSON. Let's have a look at it. Print tools. And you're going to see it's, actually what happens if I just do it like this? That might look better. There we go. It does look better. This is what tools now is. It is this big chunk of JSON, boilerplatey JSON, which describes the two functions that we're providing with a name, a description, the parameters, and so on. And this, putting things in JSON, is a language that LLMs are good at understanding because it's in lots of their training data. And so that's going to help us to be able to interact with OpenAI. So this next part is the most important part. It's also probably the most complex. Now, you're comfortable with the fact that we are going to be sending this JSON to the LLM and giving it the option to reply when it generates its response. It can opt to say that it wants to run one of these tools. It wants to run this tool, or it wants to run this tool. So the next thing that we've got to do is write a function which is going to handle what happens when the LLM responds and says, yes, I do want to run this tool, please run it and provide me with the output. So that is the purpose of this function that I've written right here called handle tool calls. And it's a function which takes a list of tool calls and it will run them. And it will add the responses to the results that it returns. So it has a loop. It loops through these tool calls. Typically, a model will only call one tool at a time, but actually the construct supports multiple tools being run. And so we want to support that here. So we do that. So we loop through all of the tool calls. We look at this, what's come back in this tool call. And I should say, this is actually, it's a structured output. It's JSON coming back from the LLM that's been put into an object. And so this is one of the reasons why I said it's very analogous to structured outputs. So back has come this JSON object. It's in the form of an object tool calls. And we are going to look at the function name that it's providing back in that response. And we are going to be calling that the tool name. And that is the name of the function it wants to call. And it also provides us with the parameters, the arguments that should be put into that function. And we can strip them out like this. And so I'm then just going to print, we're calling this tool. And what comes next is an if statement, just like I promised you. We say, if the tool name is record user details, if it wants to call this tool, then we call the function that's called record user details and we pass in the arguments. But conversely, if the tool is this tool, record unknown question, right here in the JSON, then we call the function called record unknown question and we pass in the parameters. And then we add in whatever came back from that function call into the list of messages. And that's what we return. So that is the extent of the handle tool calls function. And as I told you, it's got this if statement. So hopefully that's more concrete for you. You see that coming together. And if not, come and look through this and get comfortable with it. Okay, and what I've got next is something a bit sneaky. When you look at this, you might think to yourself, this is a bit dumb. We've got this thing that looks for a string and then calls a function with the same name, and looks for a different string and calls a function with the same name. And we know that Python is full of magic stuff. Isn't there a way in Python to do a sort of reflection thing and just call that function with the same name as that string? And the answer is yes, of course there is. And this is one way of doing it that works in this particular situation. There is this thing called globals, which gives you a dictionary which you can use to look up any function which is in the global scope. And so I can use that to look up a function called record unknown question. And that will give me the actual function, record unknown question. And I can then call it like that. This is a really hard question. So if I run this, it should send a push notification to my phone. Let's see. Yep, that seemed to work. I see, recording. This is a really hard question. So that works. Let's do it again. Oh, it makes it worth it pinging when I get emails. So yeah, there you see that this trickery works. And of course, that means that I can rewrite the handle tool calls function and do it this way so that now basically there's no more if statement. I've got that cunning piece of logic in there that plucks out the right function and then dynamically calls that function like that. And I can see that it would be better to do this for sure. So yeah, this obviously gives us a workaround to having the if statement that we had before. But I don't want you to think for 1 minute that means that this isn't just a glorified if statement, because that's all it is. Sure, we've got some trickery to use a dictionary to look up that has got around having to list things out. But at the end of the day, it's still the same thing. We're just taking some text and we're using that to map to a function name and we're calling that function. It's a glorified if statement, nothing more. So that's how this works. And I hope that this now gives you a bit of perspective of what's going on. The good news is you're never going to have to do this again after week 1 because all of the other frameworks take care of this kind of stuff for you. You don't need to futz around with plucking out JSON and turning it into function calls. That's exactly what these frameworks did. It's people that wrote stuff like this and thought, you know what, it would be easy just to put this into a nice little framework so that people don't have to worry about this anymore. So you won't have to worry about it anymore after this. But I wanted this to give you a real perspective on how it works, what's going on, so that you've got that foundation. And when you actually get to use the frameworks, you know exactly what it's actually doing. All right, now it's the moment of truth. We now read the LinkedIn profile in as before, and hopefully this is your LinkedIn profile, not mine. And then we bring in the summary text. You should change this name to be your name. We run that. And we now have our system prompt and user prompt for the LLM. And the system prompt is going to be the same as last time. You're acting as me or you. You're answering questions on their website, particularly related to their career, etc., etc. But there's a twist. At the end here, it says, if you don't know the answer to any question, use your tool to record the question you couldn't answer. And if the user's engaging in discussion, try to steer them towards getting in touch via email, record it using your tool. Now, in theory, this isn't needed because the JSON that we've written to describe the tool already gives this kind of context and describes the tool and when it should be used. But it never hurts to be repetitive in prompting. As I'm sure you know, repetition always works well. Explain things several times over because you will increase the probability that your model performs the way you want it to. You're biasing the model to be outputting tokens consistent with your objective. And it is important to always keep that in the back of your mind. We often like to talk about, the model calls this tool, and we make it sound like that it's almost got something that has true autonomy. But all that's actually going on here, and always remind yourself of this from time to time, an LLM is just something that's generating the most likely next tokens to follow a sequence of tokens. It's got an input and it's generating, like predictive text, what is the most likely text to follow this. And if we've inserted into this prompt stuff about different tools that it could call and stuff that directs it to use them, then that just means that the most likely next tokens will be consistent with that information that we passed in. And that's all that's going on. It's about statistical most likely tokens. And that really, it hurts my mind to try and think that one through because it seems so unlikely that predicting next tokens could be so powerful as to do things like calling tools. But that really is what's happening here. All right, that was a sidebar, but it's an important sidebar. You should always try and keep that in mind. And I have a bunch of YouTube videos about that stuff if you want to learn more about how next token prediction is able to achieve these things. Okay, so with all of this, we get to our chat function again. And this is where it really comes down to action, and we'll cover it in the next video. Okay, this is the single most important moment of the entire lab. So it's the chat function, and I've spaced it out a bit to really explain what's going on. It's a more powerful chat function that includes the calling of a tool. It starts exactly the same way as it did before. We create some messages. Role of system, the content is the system prompt. We add in the history from before. Role of user, the content is the user's message. And now do a pretty standard trick of looping again and again and again until a variable called done gets set to true. So it's going to keep going until done is true. What is it going to keep doing? It's going to call OpenAI. And this is the usual thing, openai.chat.completions.create. We're familiar with that. We pass in the model, we pass in the messages, this set of messages. But look, we also pass in tools. Tools is that JSON blob, that structure of JSON, which is going to be sent to the LLM saying, these are all the things you can do. This is the description of everything you can do. All right, and back it comes into response. And what comes in response might just be the output to go to the user, or it might be a response that indicates that tools need to be called. So that is what we do next. We look at response.choices0.finished And this tells us whether the LLM is finished and is done, or whether it wants to call a tool. So if the finish reason is tool calls, it wants to call a tool, then we look at the message itself, we pluck out the tool calls from it, and this is where we call that function that we just wrote, that clever function, that sneaky function. Right here it is. Remember it, handle tool calls. This is the one that is the glorified if statement, the one that has the fancy if statement. But there's also this more silly version here that just has an actual if statement. But it's going to call this. So back we go. So again, if it wants to call tools, then we do that. We handle the tool calls. We call the tools. And then into the set of messages, we put what it wanted to do and the results of doing it. And then we will loop back and call a second time. And we will keep doing this until the finish reason is not tool calls. It does not want to call tools with whatever it's just responded. In which case we return the content because that is going to be the actual response to the user. I hope that made sense. If not, go through it slowly, carefully until it does. This is pivotal. This is how the whole thing hangs together. Now I know what you're thinking. You're thinking it's all very well showing us all this code, but does it actually work? Well, let's find out. Let's run the code. Here we have it. Let's say, hi there. Hello, how can I assist you today? What's your job? I'm currently the co-founder and CTO of Nebula. Very nice. Do you have a patent? Yes, I do. Very nice. Who is your favorite musician? That's what I want to know. I hope you heard that. Success. So it says, I'm not sure what my favorite musician. I appreciate a variety. If you have a favorite, I'd love to hear about it. It called the tool. You heard my phone go. We have success. The agent was able to take that JSON. It knew that this was a tool that it could call. It was able to respond with the finished reason was tool calls. And that caused us to interpret that, to make the call to our function handle tool calls, which had our fancy code that ended up calling this function, that ended up calling pushover, that then sent the push notification to my phone. And it all hung together. All right, let's keep going. I'd like to get in touch. That's great to hear. Please share your email address. I'm at ed@edwarddonner.com. I know you're expecting it now. The magic's worn off. You're not impressed anymore. Well, I think that's really cool. So it has indeed, of course, notified me about my own email address, which is great. And so it shows you that it does hold together, and you are indeed able to have these interactions and get it to text you. Okay, that's great. I hope you enjoyed it. But next, it's all about doing this for you and actually deploying this live to production so that you can serve your own avatar on your personal website. So if you've followed everything so far, then many congratulations. If you haven't, then also congratulations, because it gives you this great opportunity to go through, work through this until you do. And if I can help, email me, contact me anytime, LinkedIn with me, message me so that I can help you out. So what I want to do now is show you how you can deploy this application in production for yourself so that you can have this as your virtual resume. Surely this is the future of resumes. No longer will we have profiles or CVs, resumes, where you list out your skills and experience, but rather you'll have a chatbot that people can interact with to learn about your career. And what better way to highlight your AI abilities and your abilities to work with agentic AI than to have an agentic solution up on your website that will allow you to interact with people and talk about your career. So let me show you some steps to deploying this. So the first thing to do is to put the code into a Python module. And I have done that right here for you in app.py. And you'll see that this has all of the stuff you would expect. It's got the same information in here, but organized into nice little functions. At the top are the functions that cover the tools that we call. And then there is a class me, as in me or you. And that's something which has the handle tool call that we know so well. That's right here. And it has the system prompt and this loop that we just went through, this chat loop that has the while not done. It calls openai.chat.completions.create. It passes in the tools. I don't think I mentioned this actually, so I'm pleased I paused for a minute here because I do want to show this one more time. We call chat completions create. We select the model, we pass in the messages, and we pass in the tools JSON, the description of the tools that it can call. And with what comes back, we take choices 0 and we look at the finish reason back in the response, and we see whether or not that is tool calls. And if so, then we loop through to make sure that we run all of the tools before calling it again to get the final response. So this is so critical, this chat with its loop, that I do encourage you to take a look at it. And now at the bottom here, we have the Gradio code. We've got it set up here so that if this is just run as it is, then it will create a Gradio chat interface with showing me.chat and with the messages, and it will launch it. So what I can do now, in fact, is I can bring up a terminal, which you may remember, you press Control and the backwards tick mark. I can go into the week 1 folder. Here we are. And I can now type, remember, you don't type Python, you type uvrun to run something in this way. uvrun app.py. And if I run that, then it should come up. So this link now, on this link, I can press Control and click it to bring it up. Up it comes. Let me make that a bit bigger for you. This is now an app running on my box. And I can say, hi there. Hello, how can I assist you? And do you have a patent? and so on. And there we go. Okay, so that works. Going back here, what we now want to do is look at actually deploying this. So there are various ways you can deploy an application like this, but one of them that's particularly simple and elegant is brought to you by the lovely AI company Hugging Face, which also happens to be the company that owns Gradio, that beautiful framework. Hugging Face has something called Hugging Face Spaces. And Hugging Face Spaces is a way that you can deploy things really simply. And then if you wish, you can also embed them in your own homepage. So it gives you a really nice, simple way to do it. So this is how you do it. You first have to go to Hugging Face's website and set up your own account if you don't already have one. So you may already have a Hugging Face account, but if not, you need to set one up. Once you've done with that, you go into the Foundations folder in a terminal and you run this command, Gradio deploy. It's then going to ask you a series of questions, a bunch of simple questions to which I've got the answers you have to give right here. And I'll go through and do it right now, but I'm not going to do it properly because one of the questions it's going to ask you about some secrets that you'll say yes, and you're going to provide your OpenAI API key so that it can use that in the deployment. And you can also give your pushover tokens as well. And then I have got the rest of the instructions right there for you. And once that's done, it will be deployed into a Hugging Face space. And you can choose whether that is public or private. You can have it be private if you don't want other people abusing your key. Although, as I say, it's super cheap. But it would have to go viral for you to have any kind of significant spend. And of course, make sure that your OpenAI account, you never want to have that auto refilling, so that if that ever were to happen, if your app did go viral, then you would be protected. And anyway, OpenAI has limits, as you probably know. So let's go and actually do this. Let's run Gradio deploy. So I'm going to bring up the terminal now, and then we will go and do this ourselves together. Okay, so here I am within Cursor, in the terminal in Cursor. It's a bit confusing. You can see that's this bottom half of the screen, and I was originally in the agents directory, and I went into the Foundations subdirectory. So that's where I am right now. And this is, of course, the same directory that has app.py. And now I type these two words, Gradio deploy. That's it. So when I run that, it's going to create a new Spaces repo for me. And now we need to give it a title for the app. And we're going to call it Career Conversation. But I'm going to call it Career Conversations 2. Because I already have a number one. Enter Gradio app file. Well, it's app.py. That is our Gradio app file. So we could just press enter to accept it as it is. Enter Spaces hardware. So we want CPU-basic. That is the simple, cheap, free, not cheap, it's free version of Gradio Spaces. You will not have to pay for this. Any Spaces secrets. And now we have to say, yes, there are spaces. Enter the secret name. So we have to type OpenAI API key. And then we have to get this right. If you get it wrong, there is a way to edit it later, but try and not get it wrong. And now we have to enter the actual value, the OpenAI API key. And I'm, of course, not going to enter my API key right now. Otherwise, all of you guys will see it right away. But I'll put in a fake key. We'll do sk-proj-blah, blah, blah. And enter a secret name. There are two more secrets that we need to add. Do you know what they are? They are, of course, the pushover user and whatever that is, and the pushover token and whatever that is. And that is it. And it says enter blank to end. So I just press enter and that's it. Create a GitHub action to automatically up the space. And the answer is no. So I can just press enter to say no. And that is now running. And it's done. The space is available at that URL, just like that. So I should now be able to click on that and launch it and see my space in action. Open. And here it is. It's still building. So it takes a minute to build. But luckily, my old one is still running over here. So I'm just going to flip over to that. You can see this is the address. huggingface.co spaces, my user ID, and then career conversation. And I can say, hi there. And it's thinking about that. And it says, hello, how can I help you? I'm going to make sure my phone is on noisy so that we can experience this. Do you have a patent? Yes, I hold a patent. I'd love to hear more about the patent. Can I get in touch? Absolutely. Share your email address. I'm Ed at edwarddonner.com. Ha ha ha. You like that? So there we go. And it's come through very nicely. And I'm happy to say that I've been alerted about my own email address. So hopefully that is clear for you. You now see that. Hang on, if I take this off, hopefully the other one has now deployed as well. Career Conversations 2 is right there. There it is as well. So I now have 2 Career Conversations. So this is how you can interact with a deployed app. And also Hugging Face gives you a great way that you can just embed this in your own website. So I have a number of Hugging Face spaces that run on my website. Like I've got this Connect 4 game that you can play against different LLMs. And this is just a Hugging Face space. But if you look, it looks like it's just coming from my own personal website. You can do the same thing. The instructions are on the Hugging Face Spaces site. And that way you can have your web page having embedded within it your career conversation where people can come to your website. They can have a virtual conversation with your avatar about your career, about your interests. If they say something that it doesn't know how to answer, it's going to send you a push notification with the question so that you know it right away. And if they're willing to give their email address, then it's going to notify you with their email address so that you can get in touch. So that is a deployed app that you have running and that you can interact with and use it as your own personal career avatar. So I know this was a lot to take in, but I hope that you found it very satisfying, a real application that you can put to good use. The more information here about how you do that deployment with the instructions, and now the exercises for you. And this is the real end of week 1 exercises that you need to take seriously because these are important. First and foremost, of course, to state the obvious, you should build this yourself. It's a valuable tool. It's really cool. You should deploy it. It is the future of resumes, an interface you can chat with about yourself. And next, of course, you should improve the resources that are supplied to the chatbot. This is very vanilla, just a LinkedIn profile. You can add much more detail about your background. You can add in lots of important stuff, and you could give answers to all of the typical career-y kinds of questions. So you can make sure that you've got a really robust knowledge base of data there. If you know how RAG works, you could implement RAG. You could put in a Chroma data store. If you've done my LLM engineering course, then you know this stuff super well. You could build that in there and you could have it doing something that has like a bunch of different documents that it's able to refer to in giving good answers with relevant context. And then you should add in more tools. You could have a tool that can make a SQL query to a database to look at prior questions that couldn't be answered, and a database where it could add in questions that require an answer. So you could have something that's quite interactive where the LLM is able to add questions to a database, and it can text you, and then it will send you a push notification, and then you can come in and add the answers, and it will then provide the answers later to the user. So you could add all of that stuff, which would be really interesting. And then the final exercise for you, of course, is that you may have noticed that whilst in the last lab, we built an evaluator, I didn't actually include the evaluator here because it just felt like that was too much for one lab. But you should now bring that back. Let's have the evaluator in there to make sure that all of the responses that people give are very professional and crisp and do well. So these are all good exercises for you to get involved in. And there's also plenty of user interface stuff you could do to make this nicer. You can make that Gradio app look prettier for sure. If you could just ask ChatGPT to give you some advice on Gradio apps. And if you know how to stream back results, again, if you've taken the other course, then you should add that in, of course, too. And to wrap this up, I just want to talk about the commercial implications. I always do want to bring it back to that. I mean, the obvious point here is that this is commercially already useful because you can use it for yourself to attract clients and perhaps even future bosses. But also you can extend this kind of thinking to any business situation where you are building AI assistants, which is one of the very most common use cases commercially for agentic AI. This ability for it to interact with the real world through tools is what really sets something from being just a vanilla chatbot on a website to being something that is actually commercially valuable. It could be something which doesn't just tell you about ticket prices to travel somewhere, but it can then actually go and interact and book the tickets. That's the kind of, that's the leveling up that you get with the use of tools and using structured outputs and providing more resources in the prompt. So this is really the bigger commercial opportunity. Look for ways that you can have this kind of tool-enabled AI assistant and see how that could be applied in your day job. And with that, congratulations. That is a wrap on the first week of this course, foundational week. Think of everything that you've built up over the course of the week, understanding what agents are and agentic patterns, orchestrating between multiple different APIs and building some of those patterns, the use of resources and tools, and then bringing them all together into an actual app that's useful for you right now. And maybe for some people, if you were learning tools for the first time, I probably unloaded a lot on you today. And I would just urge you to take it as something to give you some intuition for how this works. You won't have to do that again, but it's great to know how it works. And it's good to go through that code and see it step by step. For people that do know about tools and have used them before, maybe even you took the course, which means that the LLM engineering course, which means that we spent a week looking at tools, then this may have helped to the elegant way that we packaged up the use of tools. It shows you how we can be quite flexible with this, making the analogy with structured outputs and seeing how that fits together. And this will all help you to appreciate when we go into OpenAI Agents SDK, for example, and we're just calling tools, you'll know really clearly what's going on behind the scenes. And that is the perfect segue, because next week it is all about OpenAI's Agents SDK. And as I'm sure I will tell you then, and I'll tell you now, that happens to be my very favorite one of the agentic frameworks. So I'm so happy that we're getting to it right away. I can't wait for week 2. It's going to be a blast. I'll see you there.